through what Sir was telling yesterday, very basics of the petroleum engineering. Okay, so today what I want to cover is like what are all the various people working in the oil and gas business. What are their roles? What do they do? And how do they support the oil and gas business? Just before that, why are we doing all these things? We are doing all these things for energy, right? To power our vehicles, to power the industry, right? That's why you are doing all these things, right? Because you can see a lot of vehicles moving around in Kochi. Every vehicle requires petrol or diesel. Today EVs are coming. So what would be the requirement in Kochi per day in terms of, let's say, petrol? How much petrol is required in Kochi per day? It depends upon the number of vehicles, right? So you say that there are about 10 lakh vehicles in Kochi. So everyone will not put 1 liter, right? Of course, the scooty you generally put 1 liter. But cars, they put more than 5 or 10, depends upon like how far you want to go. In Kerala, about 1.9 crore vehicles. And each of these vehicles requires petrol or diesel. In India, if you see, there are more than about 40 crore vehicles. So what would be the requirement, right? And how much are you producing in India and how much are you importing? All these things matters, right? So let me just give you a little bit of statistics before I get into all these things. So generally the oil production that is there, it's at a global level or at a national level, you generally tell it in terms of million metric tons, MMT, million metric tons, okay. So in India, I'll tell you how much this is if you want to really quantify this, that how much it is. Now in million metric tons, it's a very small number. Like in India, we are producing approximately about 30 to 32 million metric tons of crude oil. And our import, that from various countries, we are importing close to about 235 to 240 million metric tons. Now the question is, now it looks to be a very small value, even though you say a million metric ton, you're telling it as a very small value. Now why do you want to tell it as a small value? Because it's easy to convey to people rather than telling this many number of zeros. It's a much easier number, no? When you're telling it like this. So many of the things that has been adopted, like the units, are basically from the US terminologies. Like people tell it in terms of gallons. Now why is it? Because many of the initial developments happened in the US and then it propagated and people started using US standards, and that's why many of the terminologies, if you see in oil and gas, people tell it in feet, people tell it in gallons, because these are the general US terminologies. Okay. So 1 million metric ton is equal to 7.3 million barrels. How much is 7.3 million in an Indian terminology? It's 73 lakhs barrels. Okay, 1 barrel is 42 gallons, or otherwise approximately 159 liters. It's 158.58 something, but let's round it to 159 liters. So if you see the requirement, you will see that it is 73 lakh into 159 liters. That will be around how much? Just see, 159 barrels. Sorry, 159 liters into 73 lakhs.
Here your mobile.
Just check.
Use that calculator.
Okay, now if you put this in crores, it will come 116 crore liters of crude oil. This is 1 million metric ton, is 116 crore liters of crude oil. So that will actually give you a picture of now how big it is. And when you talk about 30 to 32 and 235 to 240, you can imagine that what is the total requirement of our country. Now why is that the government is pushing for various new discoveries and improving the production from various basins? It's because if you can improve this number, you can naturally reduce this number and you can reduce the import requirements, and basically you can save a lot of money. Correct? Now in this 116 crore liter of crude oil, if you take 1 liter of crude oil, you may roughly get, this is not an actual figure, it's an approximate figure, you may get about 400 ml of petrol, about 0.2 diesel, and the remaining are other fractions like kerosene, ATF, and finally you have the naphtha and tar, etc. So I hope this is actually giving you a picture, because if you want to support India's 40 crore vehicle alone, forget the industry, 40 crore vehicle, I'm telling 10 lakh in Kochi, about 2 crore in Kerala, all India there's about 40 crore vehicles. Then you just imagine, from this you are only getting 40% of this value getting converted to petrol. And you cannot stop this. It has to happen every day. You cannot say that, okay, we take a break and then come back. No, it is something that has to happen continuously. Okay, so this is just to give you a picture. And similarly you have in gas also, like we are domestically producing 36 billion cubic meters of gas, and we are importing about 36 BCM of gas. Import, domestic. 50% is produced in the country, 50% is imported. Whereas in crude oil, it's a totally different scenario. We are only contributing about 15 to 20% in domestic production. Remaining 80% is coming in from imports. Now, which are the companies that support this domestic production? There are a lot of companies. Some of the major, you can say, the national companies, Oil and Natural Gas Corporation, then you have Oil India Limited, then you have Reliance, then you have Kane, I'm not writing all, I'm writing some of the major companies only. Then here you are importing from several countries so as to maintain this number of 235, right? So once again, crude oil generally is told in million metric tons. 1 million metric ton is 7.3 million barrels. 1 barrel, either you can write in gallons or liters, it's about 159 liters. So 73 lakhs into 159, it's about, you already saw, right? It's about 116 crore liters. So 116 crore liters, in that you may get 40% diesel, petrol. Approximately, don't take it as actual number. It depends on the quality of the crude, and it varies from place to place. If you see Bombay High, if you see Krishna Godavari, the crude that is coming, the quality of it will change this value. Okay. Yeah. So I was telling you about 10 lakh vehicles. This is an approximate figure. Okay. 10 lakh in Kochi, about 1.9 in Kerala, and about 40 crore in India. I'm just telling you this for an understanding that how much energy we are consuming and how much we have to import so as to balance this calculations. Gas is generally told in billion cubic meters, BCM. Okay. Now, if you see the oil and gas industry, there are three verticals basically. This is called as upstream. Then you have midstream. Then you have downstream. Now, like as these arrow marks are shown, now sir has yesterday shown the regions where you can find crude oil. So sir has also mentioned you where exactly it has to be drilled, right? Now, if you are drilling at a particular place and you're producing crude oil from there, then basically you are trying to bring, so your crude oil is here. You're basically trying to bring it up to the surface. Let me tell it as this is, you are here in the surface. Okay, so you're bringing it to the surface. So everything that comes into bringing this crude oil from subsurface to surface, you can call it as upstream. Nammal crude oil ഭൂമിയുടെ അടിയിലാണുള്ളത്. ആ ക്രൂഡ് ഓയിലിനെ ഡ്രിൽ ചെയ്തിട്ട് നമ്മളത് സർഫേസിലേക്ക് കൊണ്ടുവരുന്ന ഒരു പാർട്ടിന് അതിനുവേണ്ടി എന്തൊക്കെ ചെയ്യുന്നുണ്ടെങ്കിലും ആ ആക്ടിവിറ്റീനൊക്കെ നമ്മൾ അപ്സ്ട്രീം സെക്ടറായിട്ട് പറയും. After that, what you can do is once you have received the crude oil, naturally you have to refine it. I told you that you can get diesel, petrol, etc. But you will not do it at that place itself. You will have to send it to a refinery. Now, in order to send to a refinery, either you can send it by a tanker, but it's not a feasible idea. You may have to create pipelines. And in between this also you have to separate, like what sir was telling yesterday, you will produce oil, water and gas. So when you're sending to a refinery, you will basically send the oil, correct? So this midstream, that is actually taking care of the pipeline or transport. So once it reaches the refinery, then what is it that you have to do? Naturally, you have to distill it to various fractions and supply it to various peoples or petrol pumps or whoever is using those end products. You can supply it to those industries, right? So this is basically the refinery part that you are seeing it in the downstream. Now, this is something that you should be very clear with, that where exactly the crude oil is starting from and where exactly this is ending. So in order to support this entire process till this from here to here, you need a lot of professionals in the oil and gas industry to support all the activities. One person cannot do all these things, no? There are so many people required for all these activities. Then you can say that, like, there is science discipline, there is engineering, there is even, I would say, computer applications, finance, so many people coming together to support or run this industry. Okay. So it will be good if some of you can take down something, okay, because when I'm doing the calculation also, I don't see you people writing. You should have the habit of writing some points. So this is what you're seeing here. This is basically the value chain. So yesterday sir was talking mainly related to the exploration part. Like, you try to find out the crude oil, right? Explore. Once you have explored, then what is the next step that you will do? You are trying to develop that field, right? Then you go to produce. Now these are all not happening simultaneously. You do not do everything in 1 month. It will take a lot of time, probably years, to come to a production state. Like, from the time you are sending seismic waves, getting back the data, finding where are the probable places, then drilling. No, it's going to take a lot of time. Then once you finish this, then you want to transport, and then finally you want to create some value products out of this, that is with refinery, and then finally sending it to the market. So whatever we drew previously, now we have just split the previous word of upstream to explore, develop, produce, midstream to transport, and then the downstream as the refinery and markets. Now let's come to the people who are working in this domain. Now before I go to that, I just show this picture. You can see that there is a drilling rig here. How many of you have seen a drilling rig? I don't think many of you would have seen a drilling rig. This is a drilling rig, okay? And this is an offshore drilling rig, because you know that in Bombay High, in India, in Krishna Godavari, you do offshore drilling. There is a column of water, sea is there, and you have to drill from there. Then the technology will change. You cannot put this land-based drilling rig in water, no, it will sink. You need a specialized version of that drilling rig so as to drill in water. So you can see that these are the drilling rigs, and then I was talking to you about the pipeline network. So you can see that, you know, once this drilling is completed, then you will remove this. Then there is another set of production equipments that have to be placed. We'll come to that slowly. But you can see the drilling rig, you can see that there is a pipeline network, you can see that finally it's going to a refinery. Okay. So now let's see that who are all the people who are working in this industry. So you can see that there are various disciplines that is coming in picture. So you can see, let's start first with geosciences. Then you have the mechanical people. Then you have civil. you have chemical, you have all this electrical, then you have communication, electronics, IT. Then there is a person who knows little bit of all these things. He is a petroleum engineer. And there are some other sciences that are also known to a petroleum engineer. We will not, I'll come to that in the upcoming slides. But for now, you understand that geosciences, mechanical, civil, chemical, electrical and communication, electronics, IT, then petroleum engineers are basically the people who run this industry. I'm not talking about the business part, because you know that there is marketing, there is there is finance. That's naturally required in all the industries. But seeing from a scientific perspective, you can say that all these people have some or the other roles to play in this business. Okay, now let's see it one by one, that what is each of the person doing. Geosciences. Okay, now geosciences, what do you understand when you hear the word geosciences? It is something to do with what? Geology, okay. Something to do with the earth, right? Now why earth? Why geology? Because your crude oil is there below the earth. Correct or not? Now unless and until you are clear of what is there below, then forget about drilling and producing and everything. That's coming later. Unless and until you don't have crude oil, then there is no point in developing big technologies, right? So knowledge of earth system is very important. And you can see that there are many people who work under various roles in that, like exploration geologist, geophysicist, petrophysicist and well site geologist. Now these are some of the disciplines that work in the geoscience sector. Now what is it that all of these people are doing? Now this exploration geologist, so sir was telling you yesterday about like the traps and all this anticline, syncline, all these things. So the possibility of finding oil in a particular place is basically decided by exploration geologist. He looks for various clues. There could be some seepages of crude oil in the surface. So he looks for a lot of clues and then say that, okay, there is a possibility in this area for a probable crude oil to be present. So that is, it's not only that, there are many more things, but in a crude way, if you say, it is the role of an exploration geologist to say that, yes, there is a possibility in a particular place. Then comes the geophysicist who, with the support of various service industries, send out waves into the earth, take it back and then find out that where is a probable locations where you can drill for crude oil. And then comes the petrophysicist what does he do? When the drilling is going on, there is a logging, we'll talk about it later on, that is done. So you try to find out the quality of the reservoir. Sir was telling you about the reservoir. So how much quality does it have for production is decided by the petrophysicist. And then you have the fourth person who is called as a well site geologist. Now when you say a well site, he is somebody who is there in the field while drilling. Because when you are drilling, you will get the cuttings, no? The rocks will come out. You would have seen when some drilling is going on, you will see that there are some rocks that's coming out. So these rocks are critical information actually, because they are basically coming from the subsurface. So you want somebody to be present at the well site during the drilling operation. So because he can actually give a lot of information to the company and the driller. So there is somebody who will be there at the location. So he is actually the well site geologist. So these are the main four people who, there are other sub carriers also. I'm not going much into that, but if you say in a very generic way, these four are the people who support the geoscience, and I would say that this is a backbone of the oil and gas industry, because unless and until this is very strong, the further process may not be very efficient. Okay, so you can see that this is a model. So yesterday sir was telling about the various layers, no? So you can see the layers here, various layers that has been brought out in seismic and then post-processed using various softwares and algorithms, and you can see the complete layer, and then you can see the anticline and syncline, and then look for possible places for drilling. Okay, so this is about geoscience. Sir, anything you wish to add? You could add, sir. I'll go on. Okay.
I will clarify many things from them.
Okay, sure. So next comes the, so we were telling about various disciplines. The next discipline is actually the drilling completion and well services. So it's basically the mechanical people who are very much involved in the drilling process. It's not always necessary that only a mechanical person needs to be a drilling engineer. Petroleum engineers can also be drilling engineers. Even people from some other discipline can also enter. Now the reason why mechanical people are a bit more oriented to drilling is because, you know, they study the machining. In machining process, like you would have seen that, you know, there are a lot of drill bits, you know, used for drilling various things, right? Now this process of drilling is taught to mechanical people, the calculation, the torque, the force, etc. So somewhere you can upscale it and say that no, it is very much related to oil and gas drilling. Here you are doing it in a small scale, here you are doing it in a larger scale, with the calculations getting more complex here, whereas the basics of machining is taught in the mechanical engineering curriculum. That is why people from this domain are generally considered to be fit for the drilling operations. Okay, so apart from that, there are various things like completions and all. Sir will be covering about what is the requirement of all that. But for now you understand that, you know, if you want to drill, then it is not like the regular, the water well drilling. It's much more complex because you are entering a high pressure zone. In your home, how you have gas cylinders, you keep it very safely. You know? When you go out, you lock it and everything. So just imagine a place where you're producing crude oil for several years or gas for several years. You need to be very careful with it, right? So once you drill, you need to complete the well. So we'll talk about that. But for now, you understand that it is actually the mechanical engineers who are more or less fit for drilling. Okay. Now there is another reason that the mechanical people, when it comes to materials inspection and reliability, there is also one more sub vertical of mechanical, which is sometimes it's in many of the institutions it's material science engineering, but in some places there is no material science. It is taught with mechanical itself. Now it is important to know materials and corrosion. Why? Because for any engineering application, the choice of material is very important, right? Like forget oil and gas, even for your day-to-day application, like let's say you're going to buy a chair. Are you not concerned about the cushion? That how good the cushion is, whether it is leather, whether it is foam, whether it is no sponge or anything, right? So material selection is very important. Similarly, in the oil and gas or any other industry, material selection plays a very important role. Because if you do not use the right materials, what can happen? This material can fail, and then you will have to replace with a superior material that may include a cost. Let's say you're not designed your drilling rig properly. Now because of some reason, some part got broken. Now if you want to replace this, then your total drilling time is lost. Then what is that? You have to get that material, you have to replace it. So many things. Okay, so materials and corrosion also comes in to some extent in mechanical. It's also some extent in chemical also, because the corrosion and I would say that if you see it, it can come down even to chemistry also, because the more you go deeper, you come basically to the sciences itself, right? Because it is all connected. It is not that mechanical is one separate thing or science is another separate thing. Then also in this drilling equipments, you can see that there are a lot of pumps, there are a lot of compressors, there are a lot of turbines that are used to power all these things. So basically the design of pumps, the design of compressor, the design of turbines is taught in the mechanical curriculum. So for these things, the mechanical people are suitable. And also there are various pressure vessels, there are various tanks, there are various heat exchangers. What do you understand by all these things? Like if you want to store crude oil somewhere in a particular tank, now the tank has to be designed for now let's say your water tank. Your water tank is having a wall thickness, correct? Now if the wall thickness is very less, there is a chance that it can break, correct? So when you talk about oil and gas, you want to store gas in a particular cylinder. Now if you do not calculate the wall thickness of the cylinder properly, what can happen? Because of pressure, it can break. Okay, so all these things has got a lot of scientific calculation behind it. It is not that people have just kept something, you fill gas in it, oh it may stay, it may not stay. It's not like that. You have to be confident, because if the cylinder explodes, then everything around it is gone, correct or not? So then one more thing that is there in the mechanical stream, that is actually the NDT and maintenance. Why maintenance is very important? Like you take your car every year for maintenance, right? Because you want to see that the oil is changed, you're seeing whether some part is having some wear or some damage. Then you want to change those parts so that the car runs for another 1 year smoothly. Now the same is applicable in the oil and gas industry, drilling rigs, everywhere, that you will see that whether something has to be maintained or something has to be replaced, so that your drilling or production, whatever operation is there, it is all going on very smoothly. Okay, so this is mostly about mechanical, so it's mostly drilling. It is mostly rotating equipments, static equipments, material and selection, and also inspection. All these things. Right? I think many of you might have heard of this word NDT, non-destructive testing. It is like very much advertised thing in the oil and gas business, that NDT, non-destructive testing. That is, let's say you have this table, so you use some equipment and just move around it and see that whether there is any crack in it. You're not breaking the table. So it's basically non-destructive. You're not breaking the table, but you're seeing if there is any crack in it. Okay. So that is about non-destructive testing. So this is how the mechanical people are connected to the oil and gas business. The next is the civil people. So you know that the civil is mostly into construction, right? If you know that civil works or civil engineering is basically in the construction domain. And let's say, what is this? You can see that this is sea, and then you can see that there is a platform in the sea. Okay, now this is basically used to, so you can, I'll just tell you quickly. So this is the well platform. So you can see that the various wells are connected here. So the crude oil will come from the bottom, it will come here, and it will go to this processing facility. It will get split into oil, water and gas, and then water will be discarded into the ocean. It is having some regulatory guidelines. You cannot just simply throw the water. Okay, you need to treat the water, and then oil and gas will be sent through pipelines to Bombay. There are terminals where they receive this. It's called Uran for crude oil, then Hazira receives the gas. Okay. So this is basically, so somebody has to construct this, no? Somebody has to design this, and it's more crucial because you are in the sea, and let's say if because of some reason you have a high intensity wave coming and striking on this platform, and if some parts get bent, then your design is gone. So there should be somebody who is designing this in a robust way so that it serves the purpose for many years. See, in Bombay High, you discovered somewhere in the 60s, and even today you are producing many of the platforms. Okay, so it has to stand for that many years. So you just imagine how good this design should be. Correct, no? Now, so everything that civil, structural is a part of civil, marine engineering is there, pipeline is mechanical and civil together, offshore, anything in water is offshore. Okay, and one more thing I want to tell you is the technologies that are used offshore are more costlier because it's specialized and it involves a lot of risk. Okay, so basically the civil people are into construction. I'm just telling one example. Even for various other things, like even for whatever I was telling you, the pipeline, etc. Okay, maybe it's designed by the mechanical people, but the laying, the foundation for it, everything has to be done by a civil person. Okay, I'm just telling in a very from a broad framework of this. So I was telling you civil and geotechnical. Geotechnical is one subset of civil. Okay, civil has got structural, civil has got transport, civil has got geotechnical. Now, geotechnical is basically into the soil integrity. You have soil, so the soil integrity. Because if you want to place something on a soil, then the bottom portion should be strong. So they do a geotechnical survey. Okay, so that is basically this. Then I showed you structural, that is whatever the platforms, etc., something that has to be erected comes in structural. And of course the pipelines, laying and etc. So all these things together, you can say that it comes under the civil framework. Okay, so I was telling about mechanical, I'm telling about civil. We are basically seeing what is the contribution of each of the engineering and science discipline in the oil and gas business. Any question you have till here or any question you have in mind, you can stop me. മനസ്സിലായിട്ടില്ലെങ്കിൽ മലയാളത്തിൽ ചോദിക്കാം. എന്തെങ്കിലും ക്വസ്റ്റ്യൻ ഉണ്ടോ?
3 months കോഴ്സിന്
ഈ പറയുന്ന ഡിസിപ്ലിനിലുള്ള എല്ലാവർക്കും ജോയിൻ ചെയ്യാം. അതെ,
ഡിഗ്രി ഗ്രാജുവേഷൻ
ആക്ച്വലി രണ്ട് കാര്യങ്ങളുണ്ട്. ഫസ്റ്റ് എന്ന് പറയുന്നത് മീൻസ് ഏതൊരു പ്രൊഫഷനും ഒരു എൻജിനീയർ ഉണ്ടാവും, ഒരു ഡിപ്ലോമ ഉണ്ടാവും, രണ്ടാളുണ്ടാവും. അപ്പോൾ ഞാൻ ഈ പറയുന്ന കൂടുതലും എൻജിനീയറിങ്ങിനെ പറ്റിയിട്ടാണ്. ഇതിനെ സപ്പോർട്ട് ചെയ്യാൻ വേണ്ടിയിട്ട് ഒരുപാട് ഡിപ്ലോമ ITI ആൾക്കാർ വേണം. ഈ രണ്ട് പേർക്കും ആക്ച്വലി ഇതിൽ വരാം. ബട്ട് നമ്മൾക്ക് ഇപ്പം കുറച്ചുകൂടി സൂട്ടബിൾ ആയിട്ടുള്ളത് എൻജിനീയേഴ്സിനാണ് ഇപ്പോൾ ഒരു ഷോർട്ട് ടേം. കാരണം ഡിപ്ലോമ ലെവലിൽ ട്രെയിനിങ്ങിന് കുറച്ചുകൂടി ടൈം വേണം, എന്നാലും ചെയ്യാം. അതെ അതെ, ആക്ച്വലി ഇപ്പോൾ ഇതാ ഞാൻ പറയാം. ഇപ്പം ഞാൻ ഇവിടെ എഴുതിയിട്ടില്ലേ, ഇപ്പോൾ ജിയോ സയൻസസിൽ വരുന്ന ആരാണെങ്കിലും ഇപ്പോൾ ജിയോളജി, ജിയോ ഫിസിക്സ്, പിന്നെ മെക്കാനിക്കൽ, മെറ്റീരിയൽസ്, ഇലക്ട്രിക്കൽ, ICT. പക്ഷേ ഇലക്ട്രിക്കൽ, ICT, ഡിജിറ്റൽ ഇത് നമ്മൾ അത്രേ ഇപ്പോൾ പറയുന്നില്ല. കാരണം നമ്മളിപ്പോൾ നോക്കുന്ന കുറേയും കൂടിയും കോർ ബിസിനസ്സിൽ എൻ്റർ ചെയ്യാൻ വേണ്ടിയിട്ടാണ്. ഇവരെ നിങ്ങൾക്ക് എവിടെ വേണമെങ്കിലും പ്ലേസ് ചെയ്യാം, മീൻസ് എവിടെ വേണമെങ്കിലും അവർ വർക്ക് ചെയ്യാം. അവരൊരു സപ്പോർട്ട് സിസ്റ്റം പോലെയാണ് വർക്ക് ചെയ്യുന്നത്. പിന്നെ സിവിൽ, പിന്നെ കെമിക്കൽ ആണ് കുറച്ചുകൂടി ബെറ്റർ ആവും. വേറെ എന്തെങ്കിലും ക്വസ്റ്റ്യൻസ് മൈൻഡിൽ? ഒരു ചെറിയൊരു സംശയം ഉണ്ടാവില്ലേ? Next is chemical people. Chemical people are mainly into midstream and downstream. Downstream main item because they want to process this crude oil. So you have crude oil, now you want to distill it to various temperatures. So you need to do a process design. ഒരു പെർട്ടിക്കുലർ പ്രോസസ്സിനെ ഡിസൈൻ ചെയ്താലേ എന്താവുള്ളൂ, നിങ്ങൾക്കത് ഓട്ടോമാറ്റിക്കായിട്ട് പെട്രോളിൻ്റെ ബിന്നിലും ഡീസലിൻ്റെ ബിന്നിലും കെറോസിനും ടാറും നിങ്ങൾക്ക് കളക്ട് ചെയ്യാൻ പറ്റുള്ളൂ. അപ്പം ദിസ് പ്രോസസ് ഹാസ് ടു ബി ഡിസൈൻഡ് ബൈ സംബഡി ആൻഡ് ഇറ്റ് ഈസ് ആക്ച്വലി ദി കെമിക്കൽ എൻജിനീയേഴ്സ്. ഇൻ മിഡ് സ്ട്രീം യു ക്യാൻ സേ ദാറ്റ് ഫോർ ഫ്ലോ അഷ്വറൻസ് എന്ന് പറഞ്ഞാൽ ഇപ്പം ക്രൂഡ് ഓയിൽ ഇപ്പം വളരെ തണുപ്പുള്ള ഒരു സ്ഥലത്തൂടെയാണ് പോകുന്നതെങ്കിൽ ക്രൂഡ് ഓയിൽ എന്താവാം, കുറച്ച് സോളിഡിഫൈ ആയിട്ട് മൂവ് ചെയ്യാൻ പറ്റാതാവും. അപ്പോൾ നമ്മൾ എന്ത് ചെയ്യും, കുറച്ച് കെമിക്കൽ ആഡ് ചെയ്തിട്ട് അതിനെ ലൂസൺ ചെയ്തിട്ട് നമ്മളതിനെ പാസ് ചെയ്യും. അല്ലെങ്കിൽ ഹീറ്റ് ചെയ്താൽ ആ ഡെൻസിറ്റി കുറച്ചുകൂടി കുറയുമല്ലോ, അങ്ങനെ പാസ്സാവും. അപ്പോൾ അതിലും ഒരു ആപ്ലിക്കേഷനാണ്. So basically what we are seeing is we want to make a process flow. For example, this is a refinery. Okay, now in this refinery, can you think that every step is done by somebody? ഒരാൾ പോയിട്ടാണോ ഈ ഇതിൽ നിന്ന് അതിലേക്ക് പോകുന്നത്? അല്ല, അത് ഓട്ടോമാറ്റിക്കായിട്ടാണ് പോകുന്നത്. അപ്പോൾ ഈ ഓട്ടോമാറ്റിക്കായിട്ട് പോകുന്നതിന് നമുക്ക് എന്ത് പറയാം, അതൊരു പ്രോസസ്സാണ്. ഇപ്പോൾ ലെറ്റ്സ് സേ പ്രഷർ ടാങ്ക് 1 നിന്ന് 2ലേക്ക് പോയി, 2 നിന്ന് ഹീറ്റ് ചെയ്ത് 3ലേക്ക് പോയി. അപ്പം ഈ കംപ്ലീറ്റ് പ്രോസസ്സില്ല, ലാസ്റ്റ് വരെ ക്രൂഡ് ഓയിലിനെ ഡിസ്റ്റിൽ ചെയ്ത് കിട്ടുന്ന വരെ എന്ത് ചെയ്യണം, ഡിസൈൻ ചെയ്യണം, ഓട്ടോമേറ്റ് ചെയ്യണം. സോ ദ എൻറ്റയർ തിങ് ഓഫ് process design to automation is done by somebody else, but somebody has to design this. That is basically done by the chemical people. And chemical is a bit more a generic subject. This is one process. Like that you can do process for various things. Even from potato to the final chips is a process. You put potato at one place, at the another place it is packaged into the chips packet and it's going. So this is an entire process. So somebody has to conceptualize, come up with the entire flow line. So that is actually the chemical people who are doing this, right? Then you have the generic subjects like electrical instrumentation and control. So we talk about pumps, we talk about compressors, we talk about drilling rigs, we talk about so many things. Now in all these things has to be powered. ഇതിപ്പോൾ നിസ്സാര ഒരു ഫാൻ ആണെങ്കിലും സംഭവം മെക്കാനിക്കലാണ്, ബട്ട് അതിനൊരു മോട്ടറും ഒരു പവർ കണക്ഷൻ ഉണ്ടെങ്കിലേ അത് ഓടുള്ളൂ. അതേപോലെയാണ് ഡ്രില്ലിംഗ് റിഗിൻ്റെ കോമ്പണൻസും കംപ്രസേഴ്സും എല്ലാം. അപ്പം വാട്ട് യു നീഡ് സംബഡി ടു power all this, and you also need instrumentation people. Why? Because sensors, metering valves, ഇപ്പോൾ gas analyzer, ഇതൊക്കെ means നിങ്ങൾക്ക് you cannot go and see that okay 140 pressure ആയോ, എന്നാലും ശരി നെക്സ്റ്റിലേക്ക് പോട്ടെ, അങ്ങനെ പറ്റില്ല. 140 ആയിട്ടുണ്ടെങ്കിൽ ഓട്ടോമാറ്റിക്കലി നെക്സ്റ്റിലേക്ക് പോയിട്ടുണ്ടാവണം. അപ്പോൾ somebody has to design this and then only, so you need instrumentation and control. It is a subject. Like in Kerala also there are some colleges offering instrumentation and control. Now they are also part of the drilling rig. Like in drilling rig also you will find that there are electrical people, there are okay. There are instrumentation and control people, and there are data people also. There is data analytics team, there is, because continuous. From where do you get this data? You get this data from the sensors from various places to know what's happening. Then comes the petroleum people. So they know all these three things, like from reservoir to drilling to production. So this will be covered in the subsequent classes. You will have an idea, but for now you already know that what is a reservoir, what is drilling, and what is production. Okay. Then comes the last set of people, that is basically in the HSE. HSE is not an engineering. There are some colleges offering safety engineering, but it's very rare. But why all these things? Because you are dealing with high pressure, high temperature, crude oil and natural gas. All these are what? They're all flammable. But it's a mistake, Madi. Everything can get in trouble. So you need somebody to, you may be very much focused on the process, you may be very much focused on the technology, but you need somebody to tell that, no, you should have a caution, right? Not just for a very small thing, like in some malls and etc. or some, you will see that wet floor, you will see that some warning sign is there, mind your head, wet floor, like that, so many things. Why? Because they have some HSE person who is seeing that where there is a possibility for an accident, like you are doing something, right? So if you're doing it slightly wrong, there is a chance that you can end up in trouble. So he will enforce a set of practices that you will be doing it only correctly. Correct or not? Okay, so that is, and then one very important thing is environment, because you are producing oil, water and gas. What to do with this water? The water has to be discarded somewhere. No? Now, because you are drilling at greater depths, there can be a lot of harmful substances in it. There can be radioactive things in it. So you cannot just put it in some, drain and then allow it to go. You have to treat it to a certain standard, and then only you can actually discard these things. So there is environment people, there is HSE to support this entire thing, so that everything goes through very safely. And one more thing is the industry is not always perfect. People have learned from their mistakes. You would have seen that previously the car breakdowns used to be very common. Nowadays you don't find the car to be breaking down so fast. Air crashes are relatively lesser as compared to the previous years. Drilling accidents are much lesser today as compared to previous years. Why? Because of HSE practices in various industries and technology advancements so as to improvise the things. Correct. Previously, when in our childhood, you see that car breakdown is very common, but now you see that it's not happening so commonly, right? Why? Because of technology. So this is the environment and regulatory things. Then, this is just a summary of whatever I have told. So just one statement. So oil and gas carriers reward people who can connect the subsurface, the wells, the facilities, data and safety. All these things, if you connect, you can say that it is an oil and gas, and it's a highly rewarding career in today's market. Okay. So yes, sir. So that's all from my side.
So you go for a break.
Yes.
They are calling 5 minutes break, 10 minutes break.
Yes.
And after that, I will come back to you, take 20 minutes from him and ask you what did you get. Okay? If you are not able to tell also, we will revise.
Yes.
So that something goes in your mind. At least that word upstream, midstream and downstream will dwell upon it.
Yes.
By sir and Hari sir. Yes, I guess all of you understood what is the basics of crude oil. Yes? Yes or no? I want some interaction. I want some response from you. If it is yes, I want an yes. If it is no, I want a no. Yes? All of you are with me? Come on, all of you are with me?
Yes.
Yes. ഞാൻ മലയാളത്തിലും പറയാം, കുറച്ചൊക്കെ മലയാളത്തിൽ ഞാൻ പറഞ്ഞുതരാം കേട്ടോ.
This boy will not, you understand Malayalam? So
But for you I will talk in English. Yes, that is okay. So in geomechanics is a part of geosciences. Basically it comes as a part of geosciences. Geosciences, I think you have heard one of the domains that Hari sir discussed today was geosciences. Yes, geomechanics is actually a part of geosciences where you apply the knowledge of mechanical engineering, basics of mechanical engineering. Mechanics, I think engineering mechanics is something that you would have heard of in your bachelor's. How many of you are here from BTech background? All of you are from diploma? What is your background? Plus 2. Even in plus 2 also I think you would have studied some basics of mechanics. Yes? If you remember in your 11th standard, 12th standard, you would have heard some of the basics of mechanics. What is pressure? What is force? Yes? I think all of you understand what is the meaning of pressure, stress. Okay. So, what exactly do you mean by stress? What exactly do you mean by stress? നമ്മൾ പറയുന്നില്ലേ, നമ്മൾ ഭയങ്കര സ്ട്രെസ്സിലാണ്, ഭയങ്കര പ്രഷറാണ്, വർക്ക് പ്രഷറാണ് എന്നൊക്കെ പറയാറില്ലേ? എന്താ വാട്ട് ഈസ് ദ മീനിങ് ഓഫ് പ്രഷർ? ഇറ്റ് ഈസ് ഫോഴ്സ് ആക്ടിങ് പെർ യൂണിറ്റ് ഏരിയ. ദാറ്റ് ഈസ് ദ ബേസിക് ഡെഫിനിഷൻ ഓഫ് പ്രഷർ. ഫോർ എക്സാമ്പിൾ, സപ്പോസ് ലെറ്റ് us say someone is you are like a free body now. Okay, you are a free body now. Someone is actually putting some weight on you. So what happens? Naturally there will be some load acting on you. That force is actually defined as load per unit area of cross section. This is actually your basic definition for stress. Now the same stress, how do we define stress? Stress is actually For example, you have a body. You have a body or a material. Okay, you have a body or a material. You apply some load on that body. You apply some load or a pressure on that body. You apply some load or a force on that body. What happens? Suppose, let me take you as an example. Someone is coming and hitting you. Someone is coming and hitting you. Let it be a stranger. A stranger is coming and hitting you. What will you do? You will resist. Obviously you will resist, isn't it? So the same thing happens to a material. What happens is, suppose there is a load acting on a body, the body develops a resistance. The body develops a resistance to that load. So that resistance divided by unit area, means divided by area of cross section, is actually known as stress. Is actually known as stress. So stress and pressure are two terms that are actually used as an alternative, but they are having entirely different meaning. They are having entirely different meaning. Are you all getting my point? So what do you mean by stress? Stress is actually the resistive force that is developed, or the force that is developed as a resistance within the body to the load acting on the body is known as stress per unit area, means divided by area of cross section is stress. Are you all getting my point? Is it clear to all of you? Now, why am I talking about this stress, or why am I talking about this load? What is the meaning of all these things in oil and gas? Geomechanics is a subject where you actually study or observe. Like sir was saying, what did sir say? The crude oil or the resources, they are found in subsurface. They are found in the subsurface. Or you can say they are actually layers of rock. We assume, we consider it as layers of rock. Am I right? Layers of rock. So the rock is actually a material formed by grains with pore spaces. I hope all of you remember the term porosity. I think sir mentioned porosity yesterday. What do you mean by porosity? Let us take an example of sponge. I think there is no one in this room who wouldn't have played with a sponge. Sponge അറിയില്ലേ? എല്ലാവർക്കും സ്പോഞ്ച് എന്താണെന്ന് അറിയില്ലേ? സ്പോഞ്ചിൻ്റെ പ്രത്യേകത എന്താ? സ്പോഞ്ചിൻ്റെ പ്രത്യേകത എന്താ? What is the peculiarity of a sponge?
उसके ऊपर पानी डाल दो तो क्या होगा?
It absorbs. Means it is having വേറൊരു പോറസ് ആയിട്ടുള്ളൊരു സാധനം നിങ്ങളെ ദിവസവും കഴിക്കാറുണ്ട്. എന്താ? പുട്ട് അറിയില്ലേ? പുട്ട് ഒരു പോറസ് ആയിട്ടുള്ള ഒരു മെറ്റീരിയലാണ് അല്ലേ? ശരിയല്ലേ? അപ്പോൾ വാട്ട് ഈസ് ദ പെക്യുലാരിറ്റി ഓഫ് എ സ്പോഞ്ച്? It has pore spaces within it. It has pore spaces. അത് അബ്സോർബ് ചെയ്യുന്ന എങ്ങനെയാണ്? How is it absorb? How is it absorbing the fluid? It is actually taking in the fluid, and the fluid is actually occupying the pore space. It is actually occupying the pore space. So how is that rock body? How is a body formed? A porous material or a porous body formed? It is considered to be formed by various grains of rock. In between you have the space, the porous space that is occupied by the pore fluid. Is this clear? All of it is like a sponge. It is like a sponge that is holding the fluid within it. What is it doing? It is holding the fluid within it. Is this clear? Is this clear to all of you? Okay. Now, what happens is the same porous body or the rock element, okay, that is holding the pore fluid, it acts differently during the course of production. പ്രൊഡക്ഷനെ പറ്റി സാറ് പറഞ്ഞില്ലേ, ഡ്രില്ലിംഗ്, പ്രൊഡക്ഷൻ, എക്സ്പ്ലോറേഷൻ, ഹരി സാറ് പറഞ്ഞ് ഓർക്കുന്നില്ലേ എല്ലാവർക്കും ഓർമ്മയില്ലേ അതൊക്കെ? അപ്പോൾ പ്രൊഡക്ഷൻ്റെ സമയത്ത് എന്ത് പറ്റും, ഈ റോക്ക് വിച്ച് ഈസ് ഹോൾഡിംഗ് ദ pore fluid, it starts behaving differently during the course of production. And the mechanical properties change. The mechanical properties change. Now let us actually go to some basic mechanical properties. Okay, some basic mechanical properties. Now the properties change during the course of production. Am I right? Is it clear? So here comes the role of geomechanics. We are actually studying the behavior of rock or the reservoir during the course of production. Is this clear, all of you? Yes. Here you can actually see the stress on a rock element. Element എന്ന് പറഞ്ഞാൽ നിങ്ങൾ കെമിസ്ട്രിയിൽ പഠിക്കുന്ന എലമെൻ്റ് അല്ലേ? ഈവൻ കെമിസ്ട്രിയിലുള്ള എലമെൻറ്റ്, വാട്ട് ഡസ് ഇറ്റ് മീൻ ആക്ച്വലി? Element means a unit. Element actually means a unit. So here you can see the various stress acting on the rock element. Is it clear? We will see what are the different stresses. What do you mean by principal stress? I will come to that concept. Okay. So here, as you see, a rock element, see, unlike your only job now is to study, get a good job. Am I right? So that is the only load or only pressure acting on you. Am I right? But unlike you, the rock element, it is subjected to different stress. What are the different stress that can act? One is, for example, you take a rock element from this part. Okay, what is the first stress acting on it? Stress due to the overburdened rock. Means, you see, ഇവിടെ ഉള്ള ഒരു റോക്ക് എലമെൻറ്റിനെ എടുത്തു കഴിഞ്ഞാൽ അതിൻ്റെ പുറത്ത് ഇത്രയും ലെയേഴ്സ് ഓഫ് റോക്ക് അതിൻ്റെ വെയിറ്റ് ഉണ്ട് ഇല്ലേ? The entire overburden is acting on it. Am I right? അല്ലേ? ഒരു റോക്ക് എലിമെൻറ്റ് നിങ്ങൾ ഇവിടെ നിന്ന് എടുത്തു കഴിഞ്ഞാൽ അതിൻ്റെ പുറത്ത് ഇത്രയും ലെയേഴ്സ് ഓഫ് റോക്കിൻ്റെ വെയിറ്റ് വരില്ലേ? ഇപ്പോൾ നിങ്ങൾ കുറേ ഒരു ഗോഡൗണിൽ ചാക്ക് ഇട്ട് വെച്ചിരിക്കുക എന്ന് വെച്ചോ, 10 ചാക്ക് ഇങ്ങനെ അടുക്കി വെച്ചിട്ടുണ്ട്. അപ്പോൾ ഏറ്റവും താഴത്തെ ആ ചാക്കെട്ടിൽ ബാക്കിയുള്ള 9 ചാക്കിൻ്റെ വെയിറ്റ് വരില്ലേ? Am I right? So similarly, if you take a rock element, first thing would be the overburden. Second one is due to pore pressure. What do you mean by pore pressure? We will come to that in detail, but at least on a basic level I can explain. നമ്മൾ സ്പോഞ്ച് പറഞ്ഞു, we spoke about sponge. The sponge is actually holding the water or the pore fluid, correct? It is holding the pore fluid. Now what it does is, the pore fluid exerts a pressure, the pore fluid exerts a pressure on the rock grains. The pore fluid exerts a pressure on the rock grains. Rock grains എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, let us assume that rock element to be formed by certain spherical objects. Those are rock grains. അത് നമ്മുടെ ഒരു assumption-ആണ്, because that is how fundamentally a block is formed, by various various spherical objects. That is just a fundamental assumption. Is it clear, all of you? ഇത്രയും മനസ്സിലായില്ലേ? അപ്പോൾ ഇതിനകത്തുള്ള ഈ പോർ ഫ്ലൂയിഡ് എന്ത് ചെയ്യും? ഇറ്റ് വിൽ എക്സേർട്ട് എ pressure. It will exert a pressure onto the rock grains. So this blue color, all of you can see this blue color, right? This blue color actually represents the pore fluid. It represents the pore fluid. Is it clear? Now, another cause or another reason for the stress acting on the rock element. First one was the overburden. Second one was the pore pressure. Right? So third one, what could be the other reason? ഇന്നലെ സാറ് പറഞ്ഞ ഓർക്കുന്നില്ലേ, ഫോൾട്ട്, വേരിയസ് സ്ട്രൈക്ക് സ്ലിപ്പ് ഫോൾട്ട്, നോർമൽ ഫോൾട്ട്, റിവേഴ്സ് ഫോൾട്ട്. So those are actually tectonic activities. Those are known as tectonic activities. Okay, tectonic activities causes the formation of various subsurface structures. Are you getting my point? Tectonics, plate tectonics എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നിങ്ങൾ പണ്ട് പഠിച്ചിട്ടുണ്ടാവില്ലേ ജിയോളജിയിൽ, ഐ മീൻ ജിയോഗ്രഫിയിൽ നിങ്ങൾ പഠിച്ചിട്ടുണ്ടാവില്ലേ, ദ ഹോൾ ലാൻഡ് മാസ് വാസ് എ സിംഗിൾ യൂണിറ്റ്. അത് കഴിഞ്ഞ് പ്ലേറ്റ് ടെക്ടോണിക്സ് കാരണം പല ഇതായിട്ട് ചെതറിപ്പോയി എന്നൊക്കെ നിങ്ങൾ പഠിച്ചിട്ടില്ലേ? സെയിം കോൺസെപ്റ്റ്, വേർ ദ ടെക്ടോണിക് ആക്ടിവിറ്റീസ് ക്യാൻ ആക്ച്വലി കോസ് എ സ്ട്രെസ് ഓൺ ദ റോക്ക് എലമെൻറ്റ്. നിങ്ങളെപ്പോലെ സ്ട്രെസ്സ് ഫോർ യു കറൻ്റ്ലി ദ സ്ട്രെസ് വുഡ് ബി ജസ്റ്റ് ടു ഗെറ്റ് എ ഗുഡ് ജോബ്, യെസ് ഓർ നോ, study and get a good job. But unlike you, this is actually undergoing different types of stresses. Am I right? What are the different types of stresses? Can one of you name what are the different stresses acting on the rock element? The overburden stress means the stress due to the overburden layers of rock. Second one is the pore pressure. Third one is the tectonics. Am I correct? The tectonics. Fourth one is during drilling and production. During drilling and production, what happens? Again, the stress changes. The stress on the rock element changes. Drilling and production activities actually causes the geomechanical behavior of the rock element to change. Is it clear, all of you? This much is clear. Now this is where geomechanics comes in picture. I have here elaborated what are the various aspects where our subject holds importance. The wellbore stability. In simple language, what is wellbore stability? Simple language I will explain. You all would have seen how a well is drilled. Not oil well. I am not talking about oil well. I am talking about the well from where you get water. വെല്ല് കുടിക്കുക, മറ്റേ കിണർ കുടിക്കുന്ന കണ്ടിട്ടില്ലേ എല്ലാവരും? പക്ഷേ അത് എത്ര ഡെപ്തിലാണ്? കൂടിപ്പോയാൽ 10 അടി, 10 മീറ്റർ മാക്സിമം. 10 മീറ്റർ ഒന്നും പോവില്ല, അത്ര. അതിനു മുന്നേ തന്നെ നമുക്ക് വെള്ളം കിട്ടും. അല്ലേ? ശരിയല്ലേ? എത്ര അടി വരെ മാക്സിമം പോവും കിണർ? ആ, എന്നാലും ഒരു ഊഹം എത്ര അടി വരും? 10 ഫീറ്റ്. ആ, അല്ലേ? ശരിയല്ലേ? എല്ലാവരും കിണർ കണ്ടിട്ടില്ലേ? വീട്ടിലെ കിണർ വെള്ളം എടുക്കുന്നത് കണ്ടിട്ടില്ലേ? അപ്പം അവിടെ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മൾ അത്ര ഡെപ്തിൽ പോകുന്നില്ല. പക്ഷെ നേരെ മറിച്ച് ഓയിലിന് നമ്മൾ എത്ര ഡെപ്ത് വരെ പോവും? സെവറൽ തൗസൻഡ്സ് ഓഫ് മീറ്റേഴ്സ് വരെ നമുക്ക് താഴോട്ട് പോകണം. അത്രയും ഡെപ്തിൽ പോകണം. വി മേ ഹാവ് ടു ഡ്രിൽ very deeper. Actually, sir will give you overview of drilling after my lecture. So where we will be going down several thousands of meters. Okay. First application of our subject comes where we have to ensure this wellbore stability, wellbore stability has to be ensured. Karanam, it should not undergo any kind of a breakout or stuck pipe. These are different problems that you will come across in this course. Okay, it should be, we should prevent collapse, wellbore collapse. Second one, hydraulic fracturing. Hydraulic fracturing, simple coconut. For example, coconut shell in what do you observe? There is that white matter, then inside you find water. ശരിയല്ലേ? പക്ഷേ നമ്മൾ അതിൽ നിന്നുള്ള ആ വെള്ളം പുറത്ത് വരണമെങ്കിൽ എന്ത് ചെയ്യണം? തേങ്ങയെ പൊട്ടിക്കണം. You have to break the shell so as to bring the coconut water out. Correct? This much is clear. So hydraulic fracturing is analogous to that process. It is in the simplest language I am explaining, where hydraulic fracturing means you are fracturing the rock mass. So as to, for example, there are certain rock formations. ഒരു ഭയങ്കര എന്ത് വന്നാലും ഇല്ല, ഞങ്ങൾ ആ ഓയിലിനെ പുറത്ത് വിടില്ല എന്നുള്ളൊരു ടഫായിട്ടിരിക്കും. മനസ്സിലായില്ലേ? എന്ത് വന്നാലും ഞങ്ങൾ ആ ഓയിലിനെ പുറത്ത് വിടില്ല എന്ന് പറഞ്ഞിട്ട് അത്രയും ഹാർഡായിട്ട്, അത്രയും ടഫായിട്ടിരിക്കും. അപ്പം നമുക്ക് എന്ത് ചെയ്യണം? അതിനെ പൊട്ടിച്ച് ഓയിലിനെ പുറത്തെടുക്കണം. ഓക്കെ, അതിനെ പൊട്ടിച്ച് ഓയിൽ പുറത്തെടുക്കണം. അതാണ് ഹൈഡ്രോളിക് ഫ്രാക്ചറിങ് in the simplest language. Okay. Second and third application is sand production control. Sand production control simple ആയിട്ട് എങ്ങനെ എക്സ്പ്ലെയിൻ ചെയ്യാം? ഈ റോക്ക് എന്ന് പറയുന്നത് ശരിക്കും എന്താണ്? പല സാൻഡ് ഗ്രെയിൻസ്, ഞാൻ ഈ പറഞ്ഞ പോലെ പല സാൻഡ് ഗ്രെയിൻസ് കൊണ്ട് നിർമ്മിച്ചതാണ് ഒരു റോക്ക് എലമെൻ്റ് എന്ന് പറയുന്നത്. ഒരു റോക്കിൻ്റെ ബോഡി എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മൾ ഈ പാറക്കല്ല് പൊട്ടിക്കുമ്പോൾ എന്താ കിട്ടുന്നത്? പാറക്കല്ലിനെ പൊട്ടിക്കുമ്പോൾ എന്താ കിട്ടും? what is your good name? Ashish. What do you get when you break a rock? You will get tiny particles of sand. You are breaking it, right? So similarly, what happens? Sand production is a very major problem. It is a very major problem. Means along with the resources, you have to control the production of sand. For that, geomechanics is very, very important. Are you all getting my point? So this is the simplest language that I can explain. I hope all of you are understanding. Yes? Yes or no? ഇനി നമുക്ക് കുറച്ച് ഫണ്ടമെൻ്റൽ കോൺസെപ്റ്റ്സ് പഠിക്കാം. എന്താണ് സ്ട്രെസ്? എന്തായിരുന്നു? വാട്ട് ഡു യു മീൻ ബൈ സ്ട്രെസ്? ആശിഷ്, ക്യാൻ യു ടെൽ മീ വാട്ട് ഡു യു മീൻ ബൈ സ്ട്രെസ്? What do you mean by stress? The internal resistive force or the internal force per unit area is called stress. The internal force or the resistive force that is developed within the body per unit area is called stress. Is it clear, all of you? So stress means, stress is usually denoted by the letter sigma. What is it called? Sigma. What is it called? Sigma. Sigma is actually equal to what? Load. Load is usually represented by the letter P. Load per unit area. The internal force per unit area. Is it clear, all of you? What do you mean by strain? Strain എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താണ്? What do you mean by strain? For example, let us take a cylindrical object. Cylinder എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ മറ്റേ പുട്ടുകുറ്റി കണ്ടിട്ടില്ലേ? പുട്ടുകുറ്റി, സിലിണ്ടറിക്കൽ ഒരു മാറ്റർ എടുക്കുക, ഒരു ഒബ്ജക്റ്റ്, ഒരു സിലിണ്ടറിക്കൽ ബോഡി. ഓക്കെ, സിലിണ്ടറിക്കൽ ബോഡി. അതിൻ്റെ ക്രോസ് സെക്ഷൻ ഒരു സിലിണ്ടറിന് മേളിൽ നിന്ന് നോക്കിയാൽ എന്ത് ഷേപ്പ് ആയിരിക്കും? മേളിൽ നിന്ന് നോക്കിയാൽ വാട്ട് വിൽ ബി ദ ഷേപ്പ് when we observe a cylindrical object from the top? It will be a circle. It will be a circle, yes or no? So when you observe a cylindrical object from the top, what will be the shape? A circle. Okay, fine. Now what will be the area of a circle? What is the area of a circle? Pi r square. Yes, it is pi r square. Pi into what is the radius? Radius is r, pi r square. What is the value of pi? 3.14. 3.1415 അങ്ങനെ പോകും. Yes, pi. I hope all of you know this much. Correct? Pi r square. Now what will be the stress? Stress can be represented as sigma is equal to load acting on this cylindrical object, load acting on this cylindrical object, okay, load acting on this cylindrical object divided by the area of cross section, the area of cross section. Right, I want all of you to write this, the area of cross section. Is it clear? Now what do you mean by strain? Strain is actually, for example, let us take this object. There are two different types of load. എന്ത് തരം ലോഡുകൾ ഉണ്ടാവാം? What are the two different possibilities by which you can load an object? You can either compress it. All of you listen. Let us take a sponge, a cylindrical sponge. Let us take a cylindrical sponge. What are the two ways in which you can load it? You can either compress it or you can pull it apart. You can elongate it or you can compress it. The load that is actually trying to elongate it, the load that is trying to elongate it is actually known as a tensile load. A tensile load. Tensile. It is called tensile load. A tensile load is the one that tries to pull it apart. Am I right? Is it clear, all of you? And the one that tries to compress it, അതിനെ പിടിച്ച് ഇങ്ങനെ അമർത്താൻ നോക്കുന്നതിന് എന്ത് പറയും? ഇറ്റ് ഈസ് കോൾഡ് കംപ്രസീവ് ലോഡ്. ഇറ്റ് ഈസ് കോൾഡ് കംപ്രസീവ് ലോഡ്. പിന്നെ വേറൊരു ടൈപ്പ് ഓഫ് ലോഡ് ഉണ്ട്. അത് എങ്ങനെ എക്സ്പ്ലെയിൻ ചെയ്യാമെന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, ദ തേർഡ് ടൈപ്പ് ഓഫ് ലോഡിങ് വാട്ട് ഇറ്റ് ഡസ് ഈസ്, സപ്പോസ് നമ്മൾ ഒരു ഒബ്ജക്റ്റ് എടുത്തു, ഇതുപോലെ ഒരു ഒബ്ജക്റ്റ് എടുത്തു എന്ന് വെച്ചാൽ, ഇവിടെ നോക്കാം, എല്ലാവരും ഇവിടെ നോക്കിക്കേ, ഓൾ ഓഫ് യു ലിസൺ ഹിയർ പ്ലീസ്. ഇങ്ങനത്തെ ഒരു ഒബ്ജക്റ്റ് ഉണ്ട്, എനിക്കിപ്പോൾ വേറെ സിലിണ്ടറിക്കൽ ഒബ്ജക്റ്റ് ഇല്ല കാണിക്കാൻ. ഇപ്പോൾ നമ്മൾ ഇങ്ങനെ രണ്ടിനെ പുള്ളി ചെയ്യാൻ നോക്കിയാൽ അതിന് ടെൻസൈൽ ലോഡ് പറയും. എന്ത് പറയും? ടെൻസൈൽ ലോഡ്. ഇങ്ങനെ കംപ്രസ് ചെയ്യാൻ നോക്കിയാൽ കംപ്രസീവ് ലോഡ്. വേറെ ഒരെണ്ണം ഉണ്ട്, അതിങ്ങനെ രണ്ട് ഇതിലും ഇങ്ങനെ ഇതിനെ കീറാനായിട്ട് നോക്കും, രണ്ട് സൈഡിലായിട്ട് ഇതിനെ കീറാനായിട്ട് നോക്കും. മനസ്സിലായില്ലേ? ഈ പേപ്പറൊക്കെ കിഴിക്കുന്ന പോലെ രണ്ട് സൈഡിലായിട്ട് ഇങ്ങനെ ആക്കി, അതിനെ നമ്മൾ പറയുന്നത് ഷിയർ ലോഡ് എന്ന് പറയും. വാട്ട് യു കോൾ? ഷിയർ ലോഡ്. ഇറ്റ് ഈസ് നോൺ ആസ് ഷിയർ ലോഡിങ്. This much is clear, all of you? Now, we are coming to the concept of strain now. What do you mean by strain? Strain is actually നമ്മളൊരു cylindrical object ഉണ്ട്, ഒരു sponge. We are having a sponge. Okay, we are having a sponge. When you are compressing it, what do you expect? അതിൻ്റെ ലെങ്ത് ചെറുതാവും. അതിൻ്റെ ലെങ്ത് ചെറുതാവും. ഓക്കെ, അപ്പോൾ സപ്പോസ് ഇതിൻ്റെ ലെങ്ത് എന്ന് പറയുന്നത്, let us take the length to be L. The length to be L. Okay, നമ്മൾ compress ചെയ്തു. We have compressed the body. What happens? The length will reduce. The length will reduce. The length will reduce. The change in length, it is represented as delta L. Delta L. That is actually the change in length. The change in length. Delta. This symbol is called delta. What is it called? Delta. This is called sigma. Is it clear? This strain is usually represented by the symbol epsilon. What is it called? Epsilon. Epsilon. Okay, epsilon. It is the symbol used to represent strain. What is strain? Strain is actually the change in length or the change in dimension, by its actual dimension. By its actual dimension. Is it clear, all of you? ഇത്രയും മനസ്സിലായോ എല്ലാവർക്കും? മനസ്സിലായില്ലേ ഇത്രയും? There are 4 different very important properties. Very important properties. Once you complete writing, you will continue. Yes, what are those 4 major important properties that we talk about in geomechanics? There are 4 major important properties. The first one is known as Young's modulus. What is it called? Young's modulus. Young's modulus. Young's modulus spelling in the Young, Y-O-U-N-G, Young's modulus. Young's modulus, M-O-D-U-L-U-S, Young's modulus. What does Young's modulus represent? Young's modulus is a property. Any elastic modulus, either elastic modulus എടുത്താലും, any elastic modulus is actually represented as the ratio of stress upon strain. The ratio of stress upon strain. Any elastic modulus is actually a representation of stress upon strain. Is a representation of stress upon strain. Young's modulus, it decides. What does it decide? ഏതൊരു പ്രോപ്പർട്ടി നിങ്ങൾ എടുത്താലും, if you take any property for that matter, it definitely has some physical implication. Young's modulus, it decides or it determines how stiff a body is. How stiff a body is. How stiff a body is to axial loading. How stiff a body is to axial loading. അതായത് ഫോർ എക്സാമ്പിൾ ഞാൻ എന്താ നിങ്ങളുടെ പേരെന്താ? What is your name? Rohit. Rohit, for example, let us take Rohit, and what is your good name? Sagar. And you are Ashish. So let us say that Sagar is trying to pull Rohit towards him, and Ashish is trying to pull Rohit towards him. രണ്ടുപേരും ഇങ്ങനെ രണ്ട് സൈഡിൽ നിന്ന് വലിക്കുന്നു. ഫോർ എക്സാമ്പിൾ ലെറ്റ് us take that. Okay. So what will Rohit do? Rohit will definitely try to resist the load. He will resist the load. Am I right? He is made of skeleton, muscles, correct? So unlike a normal sponge, he will be stiff. Yes or no? രണ്ട് സൈഡിൽ നിന്ന് രണ്ടുപേര് വലിച്ചു കഴിഞ്ഞാൽ അങ്ങനെ അങ്ങ് കിഴിഞ്ഞു വരുമോ? ഇല്ല. വരുമോ? ഒന്നും പറ്റില്ലല്ലോ. ചെറുതായിട്ട് അവർ അപ്ലൈ ചെയ്യുന്ന ഫോഴ്സ് അത്രയേ ഉള്ളൂ. സോ യു ആർ ആക്ച്വലി സ്റ്റിഫ്. യു ആർ റെസിസ്റ്റിംഗ് that axial loading. Am I correct? You are resisting that axial loading. Our resistance to, or that stiffness of the object to this axial loading is called Young's, is actually the implication of Young's modulus. Is actually the implication of Young's modulus. Is it clear, all of you? Is it clear? Now, what is the second modulus? There are three elastic moduli. First one is Young's modulus. Second one is known as bulk modulus. Second one is called bulk modulus. Second one is called bulk modulus. Sir, is this okay, sir?
Yeah.
Yes. And the bulk modulus എന്താ? Bulk modulus, see for example, നമ്മൾ ഒരു cylindrical object എടുക്കുന്നു. നമ്മൾ ഒരു cylindrical, we are taking a cylindrical object, a rock element. Okay, let us take a rock element. You are applying load from all the three sides. ഒരു സ്പോഞ്ച് എടുത്തിട്ട് നമ്മൾ അതിനിങ്ങനെ പ്രസ് ചെയ്യുന്നു, എല്ലാ സൈഡിൽ നിന്ന് ഇങ്ങനെ പ്രസ് ചെയ്യുന്നു. യു ആർ അപ്ലൈയിങ് ലോഡ് ഓൺ ദാറ്റ് എലമെൻറ്റ് ഫ്രം ഓൾ ദ ത്രീ സൈഡ്സ്. ഫ്രം ഓൾ ദ ത്രീ സൈഡ്സ് അതിനിങ്ങനെ പ്രസ് ചെയ്യുന്നു, ഫ്രം ഓൾ ദ ത്രീ സൈഡ്സ്. സോ ബൾക്ക് മോഡുലസ് ഈസ് ആക്ച്വലി it implies the resistance of the object, the resistance of the object to volume change. What is it called? It is actually, or it implies the resistance of the object to volume change. To volume change. അപ്പോൾ ഈ സ്ട്രെയിൻ നമ്മൾ പറഞ്ഞല്ലേ, സ്ട്രെയിൻ നമ്മൾ വാട്ട് യു മീൻ ബൈ സ്ട്രെയിൻ ഈസ് ആക്ച്വലി ചേഞ്ച് ഇൻ ഡയമെൻഷൻ ടു ഒറിജിനൽ ഡയമെൻഷൻ. യെസ് ഓർ നോ? ചേഞ്ച് ഇൻ ഡയമെൻഷൻ ടു ആക്ച്വൽ ഓർ ഒറിജിനൽ ഡയമെൻഷൻ, കറക്റ്റ്? Similarly, there is a term called volumetric strain. Similarly, there is a term called volumetric strain. What is volumetric strain? It is change in volume to original volume. Change in volume to original volume. Bulk modulus is usually represented by the letter K. By the letter K. Bulk modulus is actually represented as the pressure that is acting on the object from all the three sides, the pressure acting on the object from all the three sides divided by the volumetric strain. divided by the volumetric strain. Divided by the volumetric strain. Is it clear, all of you? The pressure acting on the object divided by the volumetric strain. The volumetric strain. Correct? There will be a negative sign. What is that negative sign due to? Can someone tell? There is a negative sign in the formula of bulk modulus. എന്തുകൊണ്ടായിരിക്കും ആ നെഗറ്റീവ് സൈൻ? What could be the reason? Ashish, can you guess? Or what is your good name? Rohit, can you tell me why it is represented as negative sign? എന്തായിരിക്കും കാരണം? See, നമ്മളൊരു സാധനം ഇങ്ങനെ കംപ്രസ് ചെയ്യുന്നു. ഒരു സ്പോഞ്ച് എടുത്ത്, let us take the example of a sponge. When we are compressing it from all the three sides, there will be a tendency for a reduction in volume. Correct? A reduction in volume. So, the change in volume will be a negative quantity because the volume is trying to reduce. Is it clear, all of you? So that change in volume, to compensate that, there will be a negative quantity so that your bulk modulus overall it is positive value. Is a positive value. Is it clear? All of you understood? Yes? Now what is the third elastic modulus? We have seen two. What was the first one? Young's modulus. Second one was bulk modulus. The third one will be called shear modulus. What is it called? It is called shear modulus. Shearing. Shearing എന്താണെന്ന് ഞാൻ പറഞ്ഞല്ലേ? Let us take this object. If we are trying to tear it apart, so there is a shear load acting on it. Is it clear, all of you? Yes? The shear modulus is usually represented by the letter G or C. In some textbook it is represented as G, somewhere it is represented as C. Okay? Shear modulus. Shear modulus is actually what? Shear stress upon shear strain. Shear stress upon shear strain. Okay? Shear stress upon shear strain. Now, there is a fourth important quantity that is known as Poisson's ratio. What is it called? Poisson's ratio. What is it called? Poisson's ratio. Poisson's ratio. What do you mean by Poisson's ratio? Let us take the same sponge example. Okay. You cut a sponge in the form of a cylinder. ഒരു പുട്ടുകുറ്റി പോലെ അതിനെ കട്ട് ചെയ്ത് ആ പുട്ടുകുറ്റിയുടെ അതേ ഷേപ്പിൽ അതേ ആകൃതിയിൽ നമ്മളതിനെ കട്ട് ചെയ്യുന്നു. ഒരു സിലിണ്ടറിക്കൽ ഷേപ്പിൽ. ഓക്കെ. നമ്മളതിനെ കംപ്രസ് ചെയ്യുന്നു. രണ്ട് സൈഡിൽ നിന്നും കംപ്രസ് ചെയ്യുന്നു. വി ആർ കംപ്രസിങ് ഇറ്റ് ഫ്രം ദ ടോപ്പ് ആസ് വെൽ ആസ് ഫ്രം ദ ബോട്ടം. വി ആർ കംപ്രസിങ് ഇറ്റ് ഫ്രം ദ ടോപ്പ് as well as from the bottom. What do you expect from the side? What do you expect? What do you expect from the side of that sponge? സൈഡിൽ നിന്ന് എന്ത് സംഭവിക്കും? സ്പോഞ്ച് കണ്ടിട്ടില്ലേ നിങ്ങളെല്ലാവരും? സ്പോഞ്ച് കണ്ടിട്ടില്ലേ? സ്പോഞ്ചിനെ നമ്മൾ ഒരു രണ്ട് സൈഡിൽ നിന്ന് നമ്മൾ കംപ്രസ് ചെയ്യാൻ നോക്കിയാൽ ബാക്കിയുള്ള സൈഡിൽ നിന്ന് അതെന്ത് ചെയ്യും? There will be a bulging bulging. Laterally it will tend to bulge. Laterally it will tend to bulge. Lateral എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ആക്ച്വലി നമ്മൾ അതിനെ ലോഡ് ചെയ്യും, സൈഡിൽ നിന്ന് അതെന്ത് ചെയ്യും, വികസിക്കാനുള്ളൊരു ശ്രമം നടത്തും. എന്ത് ചെയ്യും? വികസിക്കാനുള്ളൊരു ശ്രമം നടത്തും. ഇത്രയും മനസ്സിലായോ? അപ്പോൾ പോയ്സോൺസ് റേഷ്യോ ഈസ് ആക്ച്വലി നോൺ ആസ് the ratio of lateral strain upon longitudinal strain. Lateral strain upon ലോഞ്ചിറ്റ്യൂഡിനൽ സ്ട്രെയിൻ. എന്താണ് ഉദ്ദേശിച്ചത് അവിടെ? ലാറ്ററൽ സ്ട്രെയിൻ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വാട്ട് ആർ വി ഡൂയിങ്? വി ആർ ആക്ച്വലി കംപ്രസിങ് എ സ്പോഞ്ച് ഓർ എ ഒബ്ജെക്റ്റ്. വി ആർ കംപ്രസിങ് ആൻ ഒബ്ജെക്റ്റ്. During compression, what will happen to the length? What will happen to the length? Length will reduce. It will shorten. Yes or no? Length will reduce. What will happen to its lateral dimension? Lengthൻ്റെ lateral dimension, sideways dimension എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ അതിൻ്റെ diameter ആണ്. What is it called? It's a diameter. Yes or no? Laterally, what will happen? It will tend to bulge, or the lateral dimension will tend to increase. The lateral dimension will tend to increase. Is it clear, all of you? What is your good name? ജിബിൻ, മനസ്സിലായത്? ലാറ്ററൽ ഡയമെൻഷൻ എന്ത് ചെയ്യും? എക്സ്പാൻഡ് ചെയ്യാൻ ശ്രമിക്കും. ലോഞ്ചിറ്റ്യൂഡിനൽ ഡയമെൻഷൻ വിൽ ടെൻ ടു റെഡ്യൂസ്. ഇസ് ഇറ്റ് ക്ലിയർ? ഇസ് ഇറ്റ് ക്ലിയർ all of you? So the opposite is the case during tension. When you are trying to pull an object apart, what will happen to the longitudinal dimension? Longitudinal dimension will tend to increase. Longitudinal dimension will tend to increase. The lateral dimension will tend to decrease. Diameter അവിടെ കുറയും, length കൂടും. All of you understood? Ashish, you got the point? Yes, all of you understood? Clear? What is your good name? Adil. സാഗർ. മനസ്സിലായോ ഇത്? എല്ലാവർക്കും മനസ്സിലായില്ലേ? ഓക്കെ ഓക്കെ സർ. ഓക്കെ
2 o'clock will come back.
ഓക്കെ സർ.
2 to 10. Okay, maximum 2:10.
Sir, I did not know time went actually.
You will take some more time?
Sir, I can take some more time. I have enough material.
We will stop.
Okay.
And then I will come right now.
Okay.
You come back.
Okay, sir. Okay, sir. Sir, once we have a favorite subject, then we will keep on topping. Yes, sir. Yes, sir. Thank you, sir. Thank you. Which indicates the resistance of the material or the body to axial compression or tension. Yes, to axial load or axial compression or tension. Yes. Second one is bulk modulus, which indicates the resistance of the material or the body to volumetric strain. Volumetric strain. Yes. The third one is known as shear modulus. Shear modulus is actually indicates the resistance of the material to shearing. What is it called? Shearing. Shearing is actually the type of load or the type of failure caused by tearing effect. Yes or no? What kind of load? I am trying to twist it. I am trying to twist it in opposite directions. So that actually causes shear load. What does it cause? Shear load. And what was the fourth property? Poisson's ratio. What is it called? Poisson's ratio, which is actually lateral strain upon longitudinal strain. Longitudinal strain means I took an example of a cylinder. ഒരു സിലിണ്ടറിൻ്റെ എക്സാമ്പിൾ എടുത്തില്ലേ, അത് വി ആർ ട്രൈങ് ടു കംപ്രസ് ഇറ്റ്. സോ വാട്ട് ഈസ് ദ ലോഞ്ചിറ്റ്യൂഡിനൽ സ്ട്രെയിൻ? Longitudinal strain will be equal to delta L by L, change in length upon original length, change in length upon original length. And what is the lateral strain? Lateral strain is actually the change in diameter upon original diameter. What did I say? When I am trying to compress it, compress ചെയ്യാൻ നോക്കുമ്പോൾ എന്ത് പറ്റും? ഈ ഡയമെൻഷൻ കുറയും, this will reduce, but parallelly what happens, the lateral dimension it tends to expand. Laterally അതെന്ത് ചെയ്യാൻ ശ്രമിക്കും? ബൾജ് ചെയ്യാൻ ശ്രമിക്കും. What happens? Bulging. Correct? ഇത് ഒബ്സർവ് ചെയ്തിട്ടുണ്ടോ? You would have observed. If not, you just go home, take a cylindrical sponge ഉണ്ടാവില്ലേ? I hope everyone would be having sponge at home in some way or the other, a soft material. Okay, you just go see what happens when you try to compress it. Compress ചെയ്യുമ്പോൾ the dimension on which you are applying the load, it reduces, but parallelly the lateral dimension will tend to expand, bulge. Correct? You observe it. Okay, you go home and observe it. എല്ലാവരും ഒന്ന് ചെയ്ത് നോക്കണം. മനസ്സിലായോ? അപ്പോൾ പോയിസോൺസ് റേഷ്യോ കണ്ടു. We have seen Poisson's ratio. Yes? Another property that I wanted to discuss, that is a little bit of it is very important, especially when you see the, what can you say, some hard material, something like a rock. Rock is actually a mix of several minerals. Okay, a mix of several mineral grains. You observe several mineral grains stacked one over the other. That's how we define a rock element. We have defined a rock element. Yes, for our study purpose we have defined a rock element. We cut a piece of rock from any of this layer, Are you getting my point? That's how we are using it for our study purpose. Clear? Now, what do you mean by hardness? What do you mean by hardness? When you say a material is hard, what does it mean? I just wanted to know, like, ഒരു സബ്സ്റ്റൻസ് ഹാർഡാന്ന് പറയുന്നു. ഫോർ എക്സാമ്പിൾ രണ്ട് എക്സാമ്പിൾ എടുക്കാം. Let us take two examples. Let us take a banana, for instance. Let us take a banana. Another one would be a rock. ഒരു കല്ല്, ഒരു പാറക്കല്ല് എടുക്കാം. We can take a rock as well as a banana. Which one is hard? Rock is hard. Why do we say that rock is hard? Why do we say that the rock is hard? Hardness എന്ന് പറയുന്ന property, what does it mean actually? When you take a banana, okay, you just scratch it. Scratch ചെയ്ത് നോക്കിയാൽ what will happen? You will leave a mark on it. അതിലൊരു പാട് വീഴും. നിങ്ങൾ ചുമ്മാ കൈ കൊണ്ട് ഒന്ന് ചുരണ്ടിയാൽ തന്നെ അതിൽ പാട് വീഴില്ലേ? പഴത്തിലാണെങ്കിൽ പാട് വീഴും. ബട്ട് എ റോക്ക്, ക്യാൻ യു ഒബ്സർവ് എനിത്തിങ് ലൈക്ക്, ഒരു പാറക്കല്ലിൽ ചുമ്മാ ഒന്ന് ചുരണ്ടിയാൽ നിങ്ങളുടെ നഖം പോവുകയുള്ളൂ, അതിൽ പാട് വീഴും. So that is actually the difference between the two objects or the material in terms of hardness. Your banana is a soft tissue, whereas the rock is a hard material. Hardness means it is the resistance to surface deformation. What is it called? It is actually the resistance to surface deformation. Deformation is a very common term that I will be using. I will be commonly using the term deformation. What do you mean by deformation? What do you mean by a form? Hey, you people watch cricket, no? Cricket aanu. Cricket aanu. You all watch cricket? Yes or no? No. But you would have at least heard of cricket. We say that, okay, Sachin is in form, he is now out of form. What do you mean by form and out of form? Form means in a particular shape, in a particular pattern, or shape. He is in form means he is performing well. He is performing well. Out of form means he is not performing well. A pattern or there will be some kind of a form means he is in a particular pattern, a shape or a pattern. Are you getting my point? Deformation means out of form, means there is some difference or distortion in the form. There is some difference or distortion in the form. Are you getting my point? Is this point very clear to you? Yes, so that deformation is something that I will be repeating again and again. Are you all getting my point? Yes? So we have seen some of this terminology now, correct? We have seen some of this terminology. As you can see, I am taking a body, a rock element here. You take a rock element, there are three different stresses, three different principal stresses. What do we call? Principal stresses. Principal stress means principal stresses. Principal stress means principal stresses are those stresses. See, a rock element, we are taking a rock element or a rock body. Okay, principal stress means the stresses that are acting in those directions. Stress is acting from different direction, yes or no? So principal stress means the stresses acting in those planes where shear stress is zero. See, actually an object or a body, let us consider an object or a body. You are Sagar. Who is Sagar? You are Sagar. Sagar, let us take your example. Okay. Sagar, please come and sit here. Please come and sit here. So he is in a state. He is in a particular state. Okay, he is in a state. How do you define his state? How do you define his state? He is one element. This classroom is one element. How do you define his state? He is in sitting position. He is in sitting position. What else can you say? How do you define his state? He is having a pen. He is having a watch. Yes, he does not have a notebook. He does not have a notebook. Correct? He is in a particular state. So you are defining this element. He is an element, right? In this room, he is an element. We are defining him by what terms? We are defining him saying that he is wearing a dress. He is sitting here. He is in sitting position. He does not have a notebook. He has a pen. He has a watch. In different terms, you can define his state. Am I right? You can define his state in different terms. Is it clear, all of you? Correct? Similarly, we are taking a rock element. You can go back. So that is his state in this place. That is his state in this place. Now when he went back to his place, can you define his new state? What is his new state? He has a notebook. He has a writing pad. Correct? He has a writing pad. So he can be defined by different characteristics. Correct? Similarly, you take a rock element, you define the stress state. You define the stress state at this point using a stress tensor. What do you call? Stress tensor. See, I defined his state using various methods. How did I define? He is in sitting position, he is wearing a dress, he has a pen, he has a watch, he has a writing pad. Correct? Similarly, I am defining the stress state at this point or of this rock element using the principal stresses. Using the principal stresses or stress tensor. What do you call? Stress tensor. Are you all comfortable with metrics? Metrics. Have you learned metrics in your class? You have learned? You remember metrics operations? You don't remember? Have you learned metrics? Mathematics, yes. Have you all learned metrics? Okay. So it is a 3x3 matrix. It is a stress tensor. Usually is a 3x3 matrix. You define the stress state. You define the stress state of this rock element using a stress tensor. Using a stress tensor. I am not going into deep. There is a numerical that I have prepared, but it is very lengthy and it is complicated for you right now. But we will do it. Like in a long-term class, it is worth doing such numericals. Are you getting my point? Okay? But for the time being, you understand the philosophy. You understand the philosophy. So geomechanics is actually, all of you write down, geomechanics is actually the study of how rocks deform. What do you mean by deform? Change in its pattern. How rocks deform and fail. How rocks deform and fail under stress, temperature and fluid interaction So let me ask you one simple question, all of you. Rock, you are saying that it is very hard, it is strong. Rock is strong. What happens to the same rock when it interacts with a fluid? What do you mean by fluid? First of all, let me ask you, what is a fluid? Fluid is a collective term for liquid and gas. Why? What do you mean by fluid? Simple, I want a simple definition. Ashish, can you tell me? In simple terms, a fluid is something that has the capacity to flow. That is actually known as fluid. So fluid interaction actually can weaken the rock. Means it can make the rock weaker. Weak. Are you getting my point? It can weaken the rock. Are you all getting my point? Yes? So I want you all to observe this stress strain graph. Stress strain graph means, see, stress strain graph is something that actually determines the behavior of a material under load. Behavior of a material under load. See, let me ask you some basic questions. What is your name? Jibin. Adil. You are Rohit. You are Jibin. You are Jibin. Okay. You tell me, what is the difference between, you would have seen a plastic bag. Plastic bag കണ്ടിട്ടില്ലേ? പ്ലാസ്റ്റിക്കിൻ്റെയും റബ്ബറിൻ്റെയും തമ്മിലുള്ള വ്യത്യാസം എന്താ? Elasticity. Very good. What do you mean by elasticity? Stretch ചെയ്യാൻ പറ്റും. Means, if the difference is rubber. Rubber കണ്ടിട്ടില്ലേ? Rubber, what is the peculiarity of rubber? You stretch it, you remove the load, it will get back to its original form. So any deformation is temporary. What is it? Temporary deformation. എന്ന് പറഞ്ഞാൽ പെർമനൻ്റ് ആയിട്ട് അതിലൊരു ചേഞ്ച് വരുന്നില്ല, അതിൻ്റെ ഫോമിലൊരു ചേഞ്ച് വരുന്നില്ല. Elasticity is a very good term, very good term, because it is an elastic material. The deformation is temporary in nature. Okay. Whereas plastic bag, you apply some load, what happens? Plastic bag il endu vettum? കീറിപ്പോ. കീറുന്നതിന് മുന്നെയോ വലിയും. പക്ഷേ വലിച്ച് നീ ആ ലോഡ് റിമൂവ് ചെയ്തു എന്ന് വെച്ചോ, വലിച്ചിട്ട് വിട്ട് കഴിഞ്ഞാൽ തിരിച്ചത് പഴയതുപോലെ ആവും ഇല്ല. So that is the difference. Plastic material means the deformation is permanent. What is the difference? The deformation is permanent. What is the difference between elastic and plastic material? The deformation is permanent in plastic material and temporary in elastic material. Yes or no? This much is clear, all of you? Sir, can you take some more time? Yes. You have seen shear modulus, Young's modulus and bulk modulus. Yes? Is that clear, all of you? Is that all of you clear? Yes? Now, this is a stress tensor. I want all of you to note down. This is a stress tensor that actually defines the stress state. It defines the stress state of this rock element. It defines the stress state of a rock element. The stress tensor is written in the form of a matrix. It is written in the form of a matrix. It is defining the stress state at a point on a rock element. Correct? Now you see what are the terms? It is a 3 by 3 matrix. It is a 3 by 3 matrix. It is a 3 by 3 matrix. Okay. The diagonal elements are termed as the normal stresses. The diagonal elements are normal stresses. Normal stress എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, what do you mean by normal stress? A normal stress is something that acts perpendicular to the surface. A normal stress is something that acts perpendicular to the surface. The diagonal elements are normal stresses. ഈ സബ്സ്ക്രിപ്റ്റ്, ഈ എക്സ് എക്സ് എന്ന് പറയുന്ന അതിനെ എന്ത് പറയും? ദാറ്റ് ഈസ് എ സബ്സ്ക്രിപ്റ്റ്. എക്സ് എക്സ്, വൈ വൈ, ഇസഡ് ഇസഡ്, ദാറ്റ് ഈസ് ദ സബ്സ്ക്രിപ്റ്റ്. എക്സ് വൈ, എക്സ് ഇസഡ്, വൈ എക്സ്, വൈ ഇസഡ്, ഇസഡ് എക്സ്, ഇസഡ് വൈ, ദോസ് ആർ സബ്സ്ക്രിപ്റ്റ്സ്. അതെന്താ റെപ്രസെൻ്റ് ചെയ്യുന്നത്? What do they represent? What do they represent? See, the diagonal elements, they are representing the normal stresses. Normal stresses. X means normal to x direction. X means perpendicular or in the x direction. It is in the x direction, perpendicular to YZ plane or in the x direction. XX means in x direction. YY means, sigma YY means in y direction. Sigma ZZ means in Z direction. Are you getting my point? All of you? മനസ്സിലായോ? ഇത് ഇത്രയും മനസ്സിലായോ? So those are the normal stresses, and the other term, this is called tau. This is actually called tau. Tau represents the shear stress. Tau represents the shear stress. Tau represents the shear stress in xy direction, xz direction, yx direction, yz, zx, zy. ഇതിൽ നോക്കിയാൽ sigma zz means it is along z direction, but tau zx, what is the direction of tau zx? Tau zx means from z to x. From z to x. Okay, is it clear, all of you? Understood? Tau xz means from z to x. Static equilibrium, there is a term called static equilibrium which considers e term same ആയി. For static equilibrium means ഈ tau xy എന്ന് പറയുന്നത് will be same as tau yx. Will be same as tau yx. Tau xz will be same as tau zx. And tau yz will be same as tau zy. Will be same as tau zy. For static equilibrium. Is it clear, all of you? അപ്പോൾ ഈ ഓഫ് ഡയഗണൽ എലമെൻറ്റ്സ്, അതായത് ഈ ടൗ വരുന്ന എലമെൻറ്റ്സ് ഒക്കെ എന്താണ്? Those are called shear stresses. And the diagonal elements are called normal stresses. Is it clear, all of you? Is it clear? Now, how do we determine the principal stresses? How do we determine the principal stresses, there is an operation in matrix called matrix rotation. There is an operation in matrix called matrix rotation. It is very means it will take time for you to solve. So today we are not solving that numerical, but I just wanted to explain. There is a terminology in matrix called matrix rotation. We are actually rotating the matrix. We are actually rotating the matrix. Understood? We are actually rotating the matrix such that എന്താണ് principal stress? Principal stresses are normal stresses in those planes where shear component is 0. All of you write it down. Principal stresses are those normal stresses in the principal plane where shear component is 0. എന്തുകൊണ്ടാണ് ഈ പ്രിൻസിപ്പൽ സ്ട്രെസ് ഇമ്പോർട്ടൻ്റ് എന്നുള്ളത് പറഞ്ഞുതരാം. where shear components are 0, where shear stresses are 0. Are you all getting my point? Yes, all of you understood? There is one operation in matrix called matrix rotation. എന്താണ് matrix rotation? നമ്മൾ എന്ത് ചെയ്യും? This is called stress tensor. It is called stress tensor. We rotate the stress tensor in such a way that ഇതിൽ ഏതൊക്കെയാണ് ഷിയർ കമ്പോണൻറ്റ്? ഇതിലേതൊക്കെയാണ് ഷിയർ കമ്പോണൻറ്റ് പറയും? ടൗ ഒക്കെ ഷിയർ കമ്പോണൻ്റ് ആണ്. ഓൺലി നോർമൽ കമ്പോണൻറ്റ് ഏതൊക്കെയാണ്? വിച്ച് ആർ ദ നോർമൽ കമ്പോണൻറ്റ്സ്? The diagonal elements are normal components. Yes or no? അപ്പോൾ നമ്മൾ എന്ത് ചെയ്യും? We rotate the matrix such that the shear components vanishes. അങ്ങനെ ഇല്ലാണ്ടാവും. It becomes 0. So there is an operation in matrix called matrix rotation in which we rotate the matrix so that the shear component vanishes. Then we will get some value of normal stress. We rotate this and we will get a matrix. Where we will have only normal components and the shear components are 0. This is our principal stress. Sigma 1, sigma 2, sigma 3 are called our principal stress. Now, if you take the stress state of a rock element, you can see three different principal stresses. Those are, first one is vertical stress. Vertical stress, sigma V, represented as sigma V. First one is called vertical stress. The second principal stress is your sigma H max. It is the maximum horizontal stress. If you see, they are in three mutually orthogonal planes. What do you mean by orthogonal? They are at 90 degree. Orthogonal means 90 degree. Yes or no? First one is sigma V, which is your vertical stress. Sigma H max, your maximum horizontal stress. And the third one is your minimum horizontal stress. Your minimum horizontal stress. Third one is minimum horizontal stress. Ideally, what do you mean by ideal case? Means where everything is perfect. Ideal world is a world where everything is perfect. Real world is where most of the things are imperfect. Yes or no? So in an ideal world, ideal case, usually in an ideal case, we take the maximum horizontal stress and minimum horizontal stress will be same. Okay, but there is a difference because tectonic activities. Earlier I was mentioning tectonic activities. Due to tectonic activities or formation of some faults, sir was explaining about faults, yes or no? Or some fault reactivation. Some faults can be reactivated. Reactivation of faults, yes or no? Because of those activities, your maximum and minimum horizontal stress will be different. In an ideal world where everything is perfect, these two stresses are same. Are you all getting my point? Did you all understand? ഇത്രയും മനസ്സിലായോ എല്ലാവർക്കും? മനസ്സിലായില്ലേ? മനസ്സിലായോ? ജീവനോ? മനസ്സിലായി? You, Ashish, you understood? You? What is your good name? George. ജോർജിന് മനസ്സിലായോ? ശരി. ഇനി ഈ സ്ട്രെസ് ടെൻസറിന് രണ്ട് കമ്പോണൻസ് ഉണ്ട്. There are two components of a stress tensor. There are two components of a stress tensor. There are two components of a stress tensor. എന്ന് പറഞ്ഞാൽ ഇവിടെ നോക്കൂ. Suppose you are applying some load. You are applying some load on a material. You are applying some load on a material. Okay. What kind of changes do you observe? What kind of changes do you observe? എന്തുതരം ചേഞ്ചസ് വരാം? A stress tensor has two components. First one is known as hydrostatic component. First one is known as hydrostatic component, and the second one is called deviatory component. What is it called? Second component is called deviatory component. Second component is called deviatory component. The hydrostatic component, രണ്ട് വില്ലന്മാരാ. ഒരു വില്ലൻ, what does he do? The first villain causes the change in volume. The first villain causes change in volume. Are you getting my point? The hydrostatic component, it causes the change in volume. The second villain, what is his name? His name is deviatory component. The deviatory component actually causes the change in shape. The deviatory component causes change in shape. Are you getting my point? Are you all getting my point? Yes? Understood? ഇത്രയും നോട്ട് ചെയ്തോ? Yes? Have you all noted this down? Yes? Now we will slowly move on to pore pressure concepts. Okay, pore pressure. ഈ pore pressure എന്ന് പറയുന്നത് what does it mean? See, I have drawn here a rock pore space. Rock pore space with pore fluid. The blue color indicates the pore fluid. Okay, it is a rock pore space with pore fluid. Now, let us take an example, pore pressure versus depth. Normal pressure, normal pore pressure ആണെങ്കിൽ it follows the green line. Normal pore pressure, it follows the green line, and suppose if there is any overpressure, it follows the red line, which means there the pore pressure is actually higher than the normal value, and under pressure means the dotted line where your pore pressure is lower than the normal value. Okay, so there are three cases, which means normal pore pressure actually follows your hydrostatic gradient. It follows your hydrostatic gradient. Pressure exerted by the fluid column, hydrostatic gradient. And the overpressure and under pressure, it actually, in overpressure, it will be following the red line path where it is more than the normal hydrostatic gradient. Are you getting my point? So here it is actually the pore pressure with depth. As we go deeper, you see that the pore pressure increases. Now, see, when you take overpressure means it is greater than your hydrostatic pressure. It is greater than your hydrostatic pressure, and under pressure means lower than the hydrostatic pressure. So in overpressure and under pressure, they are actually deviation. They are actually abnormal pressure. Abnormal pore pressure ne karanam. What are the reasons? What are the common causes for abnormal pressure? The common causes could be tectonic loading, could be under compaction, or you can say fluid expansion of fluid expand cheyile. Fluids expand, right? Fluid expansion can actually cause abnormal pore pressure. I would like to explain one concept. There is actually a concept of effective stress. For example, what is your name? Rohit, you tell me, I will explain a situation. Okay. Jibin wants to hit you. Jibin wants to punch you. Okay. You are not wearing any shield or any helmet or anything. What will happen to you? You will get hurt. you will get hurt. Am I right? Correct? Suppose you are wearing some helmet, some protective shield. What will happen to you? You won't get hurt. You won't get hurt. If there is any protective shield, you won't get hurt. Correct? I told you that a rock, a porous rock, what does a porous rock have? A porous rock has the pore space, the rock grains. This gray color is indicating the rock grains. The rock grains, and the pore fluid occupies the blue space, indicates the pore fluid. What does it indicate? The pore fluid. Now what happens when you are loading it? When you are loading it? What happens when you are loading it? These are the rock grains. The dark space indicates the pore fluid. What happens when you are loading it? It will deform. It will deform. It will deform. Correct? It will deform. Sigma V is the vertical stress. Is the vertical stress. The vertical stress acting on this rock element, it will cause deformation. It will cause, George, it will cause deformation. Yes? Now, suppose the porous space is occupied with fluid, pore fluid. It is similar to the case where Rohit was wearing a shield. Rohit was wearing a shield. When the vertical stress, or when some load is acting on the porous rock, when some load is acting on the porous rock, there is some component that is creating a deformation on the rock grains. There is some component that is creating a deformation of the rock grains. Okay, that is creating a deformation on the rock grains. That is called the effective stress. Effective stress is actually indicated as sigma V dash. Sigma V dash is actually equal to sigma V is the actual vertical stress that is acting on the porous rock element. On the porous rock element, sigma V is the actual stress acting on it. Okay? And sigma V dash is actually the stress that is causing deformation of the rock grains. Minus pore pressure. So which means the total load acting on the porous rock, okay, is not entirely causing the deformation of the rock grains, because part of it is actually taken by whom? Part of it is taken by the pore pressure. PP indicates pore pressure. I was explaining pore pressure, right? PP indicates pore pressure. Part of the load that is acting on the porous rock element is taken by whom? Is taken by the pore fluid. Is taken by the pore fluid. I was explaining the case where Rohit was wearing a shield. Yes or no? Jibin wants to hit him. When he is not wearing a shield, he will get hurt. When he is wearing a shield, part of the impact is taken by whom? By the shield. Yes or no? Yes or no? So similarly, part of the load is taken by the pore fluid. The remaining causes the remaining causes the deformation of the rock grains or the skeleton Yes or no? Like our tissue, muscles, all those things are actually protecting our skeleton. Yes or no? Correct? Now, there is a concept called Biot's coefficient. There is a concept called Biot's coefficient. In some textbook it is written as beta, in some textbook it is written as alpha. What happens? Biot's coefficient is explained as Biot's coefficient is explained as 1 minus Kb by Ks. 1 minus Kb by Ks. What is K? K is our bulk modulus. K is our bulk modulus. K is our bulk modulus. 1 minus Kb by Ks is actually your Biot's coefficient, where Kb indicates the bulk modulus of your entire bulk, including the rock grains and the pore fluid. Including the rock grains and the pore fluid. And Ks is actually the bulk density of your solid grains. Is the bulk density of your solid grains. Are you getting my point? This much is clear? So, there is a concept called Biot's coefficient which says that sigma v dash is actually equal to sigma v minus alpha or beta times your pore pressure. Alpha or beta times your pore pressure. Okay. So sometimes on a realistic case, your alpha will be somewhere close to 0.7 to 0.9, 0.7 to 0.9. Are you getting my point? Yes or no? This much is clear? Okay. See, there are different ways in which you can determine your pore pressure. Pore pressure prediction, one very famous method, very common method is Eaton method. Sir will be explaining a little bit of well logs. I think sir has given some exercise on well logs. Okay, well logs, one common method of well log is sonic log. So there is a travel time. What do you mean by travel time? What do you mean by travel time? Time taken by the waves to travel a specific distance. So from that travel time, observed travel time and actual travel time, we can actually determine the pore pressure. Yes. So here, this is Eaton equation, where we can use this equation for determining your pore pressure from sonic transit time, where Tn is your normal compaction trend, sonic transit time, and To is your observed sonic transit time. Are you getting my point? This is a common equation that is used to determine the pore pressure. Clear? Now another one concept that we will see today is Moore circle. Moore Coulomb failure criteria. Why do we want to determine a failure criteria? For example, can you tell me what is the purpose of determining a failure criteria? We are setting some failure criteria, right? In college or school, you would have seen what is the failure criteria. You have to score above 40, yes or no? You have to score above 40 marks, then you will pass. Otherwise, it is a failure. It is considered as a failure. Correct? So that is a failure criteria set by your school or your college. Correct? You have to score above 40 marks. Similarly, in rock or in any earth materials, we are actually setting a failure criteria, a Moore Coulomb failure criteria, which we determine using triaxial test. Using triaxial test. This is actually a triaxial testing facility where you put the rock, a cylindrical rock, inside a chamber. We give a confining pressure. From all the three sides. We give a confining pressure from all the two sides, and there will be an axial loading. It is indicated by sigma 1, your axial loading, and there will be confinement from all the two sides. From the remaining two sides, there will be a confinement. It is actually called triaxial test. Okay, and we will be loading it. We will get a specific value of sigma 1, sigma 3. We will get some specific value of sigma 1 and sigma 3, based on which we will be drawing the Moore circle. To determine the failure criteria. So if within this envelope, within this region, the rock is safe. Beyond this, the rock fails. So it is like your university. You have to score above 40, you pass. Below 40, you fail. Yes or no? Correct? Is this clear, all of you? Yes or no? Now the properties, like I have shown you triaxial testing, right? A triaxial testing can be used to determine your geomechanical properties. What are the key geomechanical properties that we said? Young's modulus, bulk modulus, shear modulus, then Poisson's ratio. Yes or no? Poisson's ratio. Now, the same thing can be determined using dynamic method. Triaxial testing is called a static method. There is no movement of any waves or anything. Now, dynamic method means we actually use wave propagation for calculation of properties. Which means there are two type of waves. Sir, should I touch that part, sir?
You did body wave and
surface wave. Yes, sir. So there are two type of waves, body waves and surface waves. So in body waves, there are two types. One is called shear wave, the other one is called primary wave and secondary wave. Primary wave is something that propagates in the form of compressions and rarefactions. Compressions and rarefactions. Shear wave has a sinusoidal propagation pattern. Are you getting my point? Yes? So the waves can be used. The waves actually propagate or move with a specific velocity. The waves move with a specific velocity. Yes or no? The waves travel with a specific velocity. What is the wave, sound wave velocity in air? In air, sound moves with what velocity? You should have learned in your school. Sound wave velocity in air 330 meter per second, right? Sound wave propagates in air. Yes or no? And what is the peculiarity of sound wave? It requires a medium for propagation. It requires a medium for propagation. Unlike light is an electromagnetic wave, right? Light is called an electromagnetic wave which does not require a medium for propagation. What is the velocity of light, speed of light? 10 raised to 3 into 10 raised to
5.
almost close. 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. That is the sound of light. That is the speed of light. Speed of light. It takes 8 minutes for the light to reach from sun to earth. How much time does it take? 8 minutes. Yes or no? Yes or no? Clear? Yes. So the sound waves propagate with a velocity. In different medium, it propagates with a different velocity. We can actually use the wave velocity to capture the properties. We can use that wave velocity to capture the properties. Is it clear? All of you, is it clear? Yes? Pakka? What about you, Ashish? Is it clear? Yes. Sir, now I will move to gas rates little bit.
We will do it.
Okay.
Let me start at 3 o'clock.
Okay, sir.
And then you come because I cannot speak for 2 hours.
Okay, sir. Okay, sir.
So give them a break.
Okay, sir. Okay. You can take a small break.
5 minutes only.
5 minutes.
7 minutes.
Then you come back. Then we will start. Sir will start with drilling. Sir will start with.
Has given you an understanding how the subsurface looks like, because the oil and gas is there in the subsurface only. I told you that a four-way closure, you remember, a four-way closure or a fault closure is seen by a bird, and this is surface, this is the subsurface, so this is depth. It can see at a level the four-way closure, correct? And it can see another level the same four-way closure as we go deeper, if it exists. And we need to drill this to get the hydrocarbon. It can be one zone, it can be multiple zone. Now, we will try to draw that how the subsurface looks like. The subsurface looks like this, and if you are not understanding, please let me know. The subsurface looks like that there is a surface here, and then there is something which is called lithology. This is a porous medium, which is sandstone. You can write, it's a porous medium which is sandstone. He brought the term sandstone many times. If it is a compact medium, the cap rock yesterday, which don't have pores, it is called shell. Shell. So these are the two types of rocks we will be dealing with. One is sandstone, other is shell. There can be other type of rocks also, but we will be talking about sandstone and shell alternation in the subsurface. So this is once again sandstone, and this is once again suppose shell, and this is sandstone. Sandstone is the porous medium, that means it has pores to hold the hydrocarbon. It has pores to hold the hydrocarbon. The shells don't have pores, so it can act as a cap rock. It can act as an impervious rock where the hydrocarbon will not migrate. It will stop. It will hold the hydrocarbon. I told yesterday. Now let us, this is depth. This was my surface. I was trying to look here. This is my prospect. This is my prospect at two different depths. This is suppose 0 meter. This is 100 meter. This is 200 meter. This is 300 meters suppose. This is 400 meter. This is 500 meter, and so on. I am not able to understand, or I will not drill deeper. I'll drill up to 500. Why I'll drill? I've given you a diagram. I have a structure which is called a rig. I have a structure which is called a rig, which will help me to drill that brown color figure, sir. Yeah, that I have to bring it there. If I find hydrocarbon is there in the subsurface, I will, through this, I will drill it, and I'll explain that diagram. Now let's observe here that as I go deeper, maybe this is filled with oil. This is filled with oil. Shell cannot have oil because it is massive. There is no pores. This is filled with oil, and this is filled with water. Draw it. In your copy it will remain. This is filled with oil, this is filled with oil, and this is filled with water. The sandstone, 2 is filled with oil and 1 is filled with water, and in between there is shell. Okay, so from here to here, I have oil. Am I correct, sir? I have oil here. I don't have oil here, but I have oil. The last seen oil is at 300 meter. The last seen oil is at 300 meter. Are you clear, sir? So it is called gross pay. The word pay means, in meter, the word pay means that it has hydrocarbon. The word pay means the zone up to which we have hydrocarbon, and that is 300 meter. The net pay means the zones which have hydrocarbon. How much will be net pay? Zones which have hydrocarbon, their thicknesses. What is the total thickness? 100 meter and 100 meter, correct? 200 meter. So I am trying to explain you through this nice diagram that there is a difference between gross pay and net pay. Those two sandstone bearing zones has hydrocarbon. One has water. I am not interested in water. If I perforate in water, I am thrown out of the company, because my job is to bring hydrocarbon, oil. Now, there are two more terms which are used in the oil industry. One is called gross sand. Gross sand. Can any one of you guess what is the thickness of the gross sand? from here to here. Look here, sir. From here to here, there is sand. Okay? So gross sand is how much meter? 500 meter. Another term is net sand. How many meter net sand? Sir, how many meter net sand? Huh? Very good. Net sand is 300 meter. This one, and this one. Okay. So I brought to you a concept which many oil industry people may not know, but you know that there are 4 terminologies when we drill through the subsurface: gross sand, net sand, gross pay, net pay. Draw it properly if you have not drawn. It's not there in book. I have gone into the subsurface. This is surface. I have found oil through drilling. Through what we drill? Rig, which is that diagram. We drill through rig. And I'll explain that rig. You don't have the diagram, I think. So this is a rig. Okay? And we will drill through this rig. What are the components in that? I will explain you. But why we should drill? Because there is oil in the subsurface. How many zones has oil? 2 zones. Okay? But the word pay means oil. Gross and net has different connotations. Clear? I also told we are drilling through rig. Remember? That structure, permanent structure I'll bring and I'll drill through. But before that, I told you the antiform, from the syn form, hydrocarbon has moved through the pore spaces. Correct? And I cut a rock piece here. So if the rock piece is looking like this, and I have pore spaces, okay? If this rock piece has a volume V, and these pores which are gap, he talked about a concept called sponge. In that sponge, there are pores. There are pores. Those pores, what is filled in this? Hydrocarbon. But which are the pores which are connected? Only these 2. These are isolated. So if the volume of the pores, whether they are connected or not connected, is delta V, and the volume of the entire rock mass is V, then porosity, he was using the word porosity, is a ratio between delta V and V. Okay, very important to understand how much hydrocarbon is there in the subsurface, and we will do that exercise. Is it clear? So there are 2 terms, porosity and effective porosity. Effective porosity is only this volume which is connected. So this is delta V dash by V. That means this part is delta V dash. Is it clear to you? Pores which are connected only, I am taking delta V dash. Total matrix V. Delta V dash by V is porosity. Okay? Effective porosity. And there are some non-connected pores also. So if I take all the pores, it is delta V. Delta V by V is porosity. Effective porosity is V dash, delta V dash by V. Clear? So we came across 3 terms: net pay, we came across a term called porosity. And porosity is a dimensionless quantity because it is a ratio by ratio. But we express porosity phi in terms of percentage. How much percentage of the rock has connected pores? How much percentage of the rock has connected pores? Very important for us to know. Okay? There is another term I am bringing which is called saturation. Saturation. Sir, where will oil be there? Within the pores, na? Not in the matrix, it is solid. So, saturation is the percentage of the pore space occupied by oil or gas. So, there are three saturation: saturation of gas, saturation of oil, saturation of water, which should be equal to 1. Obviously, if my pore spaces, some is filled with gas, some is filled with oil, some is filled with water, or they are intermixed, so my entire saturation is 1. So if I in a sponge, what did I tell? That you dip it in water, it will fill with water. You dip it in oil, it will be filled in oil. Where they will stay? In the pore spaces. So I brought another term called saturation. Okay? I brought a term called net pay. Have you copied it? Yes, no? Now if you have copied it, we will try to estimate in this four-way closure how much is the hydrocarbon. My management will ask, Clemmy sir will ask, do you want to drill it? So I have to have an answer that this much million barrels of oil is there, and I will explain him why I should drill it. Okay? So this is filled with, suppose, hydrocarbon. What is the amount of hydrocarbon? Hari sir was talking numbers, this much barrels. But I need to calculate that, and I will give you the trick to calculate it right now, so that you will not forget. So what did you understand? Effective porosity, you understand net pay, you understand saturation. Okay? And you understand what is net sand, what is gross sand, what is net pay, what is gross pay. We will not be interested in the water zone. We will be interested only in the oil zone. Okay? Is this clear to you? Okay. And this also has an area. I can do a planimetry and I know what is the area through a study called seismic. I am not going into detail. I hinted a little bit yesterday. But I know the area. Now we'll do a calculation that how much hydrocarbon is there in this four-way closure. I'll not do, you will do. I'll show you how to do. And that is the reason for drilling. Can I rub the board? Put your full concentration. Many of your friends, many of our faculties, many of our students will not be able to do it. So let us concentrate. This was my surface and it is depth. Depth is increasing. I am looking for oil and gas. One of the bird is here. He is looking, bird. Looking like a fish, but it's a bird. Okay. In a water zone, you will be a fish, but let's put a bird. Okay? Who is looking in the subsurface. And it is seen that this plane, there is a four-way closure. Okay? We can find out its area. And this zone, another plane, there is a four-way closure. Between these to this, there will be a gross pay and net pay. Obviously. So, if the net pay is 10 meter, gross pay may be 70 meter, I am not interested. Net pay is 10 meter. The area of this oil pool, I have proved it as an oil pool. Assume it at this moment. Area is 20 square kilometer. That means it is 20 into 10 to the power 3 square meter square. Correct? Agreed? With your little bit of maths knowledge, it is correct? Or this is 20 into, Hari was telling, million meter square. 1 m, 10 to the power 3, 2 m, 10 to the power 6, b, 10 to the power 9, and t is 10 to the power 12. Don't confuse with 1 m and 2 m. So this is 20 million meter square is the area. Net pay is 10 meter. And entire thing, I explained you saturation. SO plus SG plus SW is equal to 1. But let's assume it is 100% filled with oil. And saturation is 60%. Okay? And your porosity, effective porosity, always see whether this E is there. Effective porosity is 18%. Effective porosity is 18%. Now, in the subsurface for this prospect, what is the original oil in place we will calculate. Okay? So, area is in square kilometer. The net pay is in meter. Okay? The porosity is in percentage and saturation is in percentage. This should have been enough to calculate what is original oil, but it is not enough. Why? Because those who have read a little bit of physics understand that when the oil is there in the subsurface and we calculate it in the subsurface, there is a change in volume. Okay? That volume to volume change is known as formation volume factor. So, they should be divided by formation volume factor in case of oil. In case of gas, it should be on the numerator. Because oil shrink. If you bring oil from the subsurface to the surface, oil will shrink. If you bring gas from the surface, subsurface to the surface, it will expand. So remember, oil shrinks, gas expand. Okay? So this is a good enough parameter to calculate the original oil in place. Now, what will be the value coming? In cubic meter. Because this is meter square, this is net pay is in meter, so it becomes meter cube. This is percentage and this is percentage. This means this is 0.6 and this is 0.18. Okay? 60% means 0.6. Now can you calculate what is the original oil in place? Do it. Do. All of you with your A mobile, please do it. You have a mobile? Yeah. Do it. You don't have a mobile? I have two mobile. Do it. In meter cube, your answer should be. Remember, it will be some million meter cube. So it will be 20 into the net pay, which is 10, into 0.6 into 0.18 million meter cube. करना पड़ेगा. It should be, what is the area? 20 million meter square. So this meter and meter will make it meter cube. Forget this million, it should be 20 into 10 into 0.6 into 0.8. Tell me the number. And it should not take so much of time. Yes. $200 into 0.6 into 0.18. What is the number? Huh? 21.6. 21.6 BB meter cube. Meter cube. Now, as I told you, if you multiply 21.6 into 62.29, then it will be million barrel. Do it. $30,000 nahi. How can it be 30,000? 21 into 6 roughly 126. Roughly it is 130 million barrels. Okay. Now this 130 million barrels, am I correct or not? This 130 million barrel is there in the subsurface. So only some percentage you can recover during the entire life of the field, and that is called recovery factor. So if you can recover 18%, then recovered resource which you can actually bring to the surface will be 130 into 0.18. Do it. 130 into 0.18. How much?
23.4.
Huh?
23.
23. That much you can recover to the surface. If you think in the night and practice it, you'll never forget. You want 2 minutes to think, do it. Any question is there? Because nobody will tell you in this way. It is not written in the books in this way. Do it. Are you okay or you are confused? Okay. Face doesn't look like. ठीक है? How do you convert barrels? You multiply cubic meter with 6.29. ठीक है? And you get barrels. Question? ठीक. And that is the reason for drilling it. So much of hydrocarbon is there, so I need to drill it. So to drill it, I have 3 phases. I will do some geophysical exploration, which I'm skipping right now, called seismic. I introduced a little bit yesterday, and I need to drill it. For that, without going into much detail, I still can help you out that how this rig will help me to drill. This rig will help me to drill. This is a structure which I am putting to drill, and it has couple of components. You can see it. The first component is this structure which is called, it's a mechanical structure which is called derrick. It's a mechanical structure which is called derrick. Are you able to see it? Why? Where is your photo? Okay? Look into me. Look into this. It has a crown block and it has a, which is traveling block. It has a crown block, it has a traveling block. You look at me, don't be. The crown block is permanent. It is not moving. That is the word crown block. The traveling block is a pulley, both are pulley, is moving. What it moves? It moves wires, in simple language. So it moves wire lines. If you see it here, there is something called a drawwork, which is a winch. There are 2 lines. One is a dead line, one is a active line. And this pulley, both the pulley in conjunction moves the active line. Okay? And what you see here is drill pipe. You need to send pipe through the holes and rotate the pipe. At the bottom of the pipe there is, this is drill pipe which is adjusted to this drive, top drive. You can see that blue one. The pipe we have handled here. Okay, there is a drill pipe below. It is adjusted to the drive. You can see it here. There are drill pipes, blue color. Are you see the drill pipe? You can see it adjusted to the drive. And at the bottom there is something called bit, B-I-T. I'll come to the blowout preventer little later. Bit, the bit rotates. It is cutting the rock. But to cut the rock, it requires a fluid, because this abrasion will create a lot of heat. So we use something which is called mud. You have seen mud? That mud will make the bit cool and bring the cutting to the surface to study the cuttings. What type of oil is there? Is oil is in this rock? I talked about the rock, he talked about the rock. It is coming to the surface. Many of time he talked about pressure. Simple language I am telling. The pressure can be very high than the prediction. Where is this pressure? The pressure is maybe hidden in this shell. There may be pockets of pressure, high pressure, which I didn't anticipate. So if there is a high pressure, this all will get collapsed. So to prevent the high pressure, in dislodging the drill pipe, I have something called blowout preventer, which prevents the excess pressure, the abnormal pressure. He has talked about various type of pressure to save the drilling operation. Simple language I used. What did I use? I used that there is a structure which is called rig. The land rig and the water rig are different. If we have time, we'll show some. Water rigs are different. I need to drill a hole, stable hole, without caving. Caving, you understand? I have no rugosity. It's not caving out. I need to drill a hole to bring the hydrocarbon out. For that I need a structure, mechanical structure, huge one called rig. The rig has two pulleys, travelling block and crown block. The crown block adjusts between the two lines. One is an active line, you can see both sides, and one is a passive line which goes to the drawwork. On your left side is the drawwork. Okay, and there is also a system for the drilling fluid to pass through inside. What is that? Mud. Okay, we need to have many pipes, drill pipes, to be jointed, bolt and screw, which goes into the hole. It passes through the blowout preventer, and at the bottom there is a bit, BIT. That bit rotates as I give it a torque. And who is sitting there? A driller. He will tell what will be the revolution per minute, which is called the rate of penetration. How much should be penetrate? So there is a prognosis. Beforehand we have to do it. And for that I have given you a second sheet which is called a geotechnical order. That is done before the drilling. Okay, it talked about the lithology, like I have drawn sandstone, siltstone, shale. What are the type of rock you will encounter, that blue colored. On the left, the panel. On the left, that panel, very good. It will also talk about how will you drill. And I have not come to another thing which in a simple language I'll tell, which is called the casing. The casing, if you drill a water well also, have you seen in your house if you have drilled a water well, if you don't case it, it will blow it off. It may get collapsed. But in this case, I am putting casing to prevent it. Casing to prevent the hole in not getting collapsed. Okay? So I am talking about a rig which has very basic minimum. It has lot of things. Basic minimum I have told you. And I have to make the hole stable, so I will do casing. I'll show you some diagram on casing. Try to understand. And I have also thought beforehand how the casing will look like, which is the second figure. Second figure, sir. Yeah. So you spend some time on that in the night, that what are the components. It has told you how the drilling will happen, where you will bring the pipes up and change the pipe, change the bit, what type of casing it will happen. So let's look into a casing. Look into this figure. What is the hole? The hole was very wide in the beginning. This figure is simple. The hole was wide. Then I narrowed it down, and then I narrowed it down. Through this hole, what will I bring, sir? I have drilled a hole. What will I bring? Huh? What will I bring to the surface? Why I am drilling? To bring hydrocarbon. But it doesn't come like that because I need to perforate also, but I am not going. Objective is to bring hydrocarbon. But there is mud also, which brings you the cuttings to study. Why is this casing done? To make it stable. How many casings are done? 1, 2, 3. All the casings, the diagram has to improve. All the casings has to go to the surface. Remember, a casing goes to the surface. Okay? I cased it, it should be going to the, but a liner can hang anywhere. You write in your diary, casing goes to surface. So a casing will look like that. This is the first casing. It will go to the second casing. One side I am showing, and this is the third casing. First casing, second casing, and third casing. Okay? Similarly, it will be on the other side also. It will be replication of the same, which you are saying. What I am telling, casing goes to the surface. If you want to adjust, why is the casing? Just that the hole don't collapse. These are the things which is called casing shoe. आप भी शू पहन के आए, casing को भी हम शू पहना देते, ठीक है? This is also called casing shoe. The shoe, on the shoe, I do a test which is called the integrity test, right? Integrity test. I want to see that the hole is stable, it is not getting rugosed. Rugosity means it can collapse. Even if you drill a water well in your house, you still case it with PVC. Okay? So casing is must. Now the casing protects your well not from caving. Okay? Why we have drilled the holes? To bring the hydrocarbon out. Okay? So this is a little bit of understanding on the drilling. Another thing which is very important, as I told, I rub the picture, I may have 2 or 3 zones to produce together. So remember this remember this diagram. Sorry. There are 2 zones here. Zone 2 and zone 1. Both should be producing. I can produce both the zones together. I can produce both the zones together. I can produce through this, okay, one string, second string. The second string goes to the second zones. I have drawn 2 pictures, 4-way closure, at a deeper depth also a 4-way closure. Now to isolate these 2 zones, I require something which is called a packer, which is in rubber, which is a rubber. Okay, so I isolate these 2 zones, produce it together. Why different production? Because the oil here may be light, the oil here may be a dense oil. The oil property may be different, but I can produce through a single well. Draw this.
I have asked them even a glazing.
And if you can make 9 copies.
Yes.
9 copies.
9 copies in a pure scan and send it.
Okay? Done? So what I will summarize here, and then I'll go to the next part, that I first bring a concept called porosity. That is a volume by volume. I brought two porosity concepts. One is the porosity, which is delta V by V. I also talked about effective porosity, which is delta V dash by V. I told porosity is given in percentage. I told that the pores can be filled with water, oil or gas. But if it is 100% filled with oil, the gas and water is 0. SO is suppose 66%, not 100%. So 66% of the pores is filled with oil. I talked about net pay, gross pay, net sand and gross sand. I talked about the importance of net pay. I also told what is the area of the pool which has to be found from seismic. Once this is found, we calculate the original oil in place in million meter cube. The area is given in square kilometer, the pay in meter, the porosity in percentage and saturation in percentage. Original oil in place also need to be divided by formation volume factor, because the oil in the subsurface will have a different volume in the surface. Okay? So there is a shrinkage of oil in the surface and expansion of gas in the surface. I told that in order to drill the prospect, I require a rig which has various components like a crown block and a travelling block. There is a derrick, there is also on the left side there is a draw box, there is mud pump and mud circulation, and then there is something which is called a blowout preventer. Below that we have the stems continue, and the end of that drill string we have bits. The bits are used for cutting the rock. We are using mud to lubricate the bits and bring the cuttings towards the surface. I also told that we can flow one of the zone or flow two zones. It can be one string or dual string separated by packer. Before we break for today, because I don't have 3 people more here, I'll show you a video to make you appreciate that after drilling, we go for something called logging, L-O-G-G-I-N-G, लिखो. He has touched upon logging. Sir, एक मिनट आइए. Let's run a video for log.
Okay, sir.
Go for well logging. No, not that, not that.
No.
Last one. This has sound?
Nice. Some.
Look into this. Now I'm logging after drilling.
Millions of dollars can
Where
be spent
is the
drilling
photo?
an oil or gas well, so it is very important to gather as much information. As possible at every stage to determine if it makes good business sense to continue drilling and complete the well.
No, I will start from
The
beginning.
well is one very effective way of oil and
Look into it very carefully.
Millions of dollars can be spent drilling an oil or gas well, so it is very important to gather as much information as possible at every stage to determine if it makes good business sense to continue drilling and complete the well. Logging a well is one very effective way oil and gas companies gather detailed information about the different layers of rock they drill through. This gives greater certainty about whether or not hydrocarbons are present. If the well is not promising, the process can be stopped and the well abandoned before incurring the large costs of completing the well. Once the well has been drilled to its target depth, the drill pipe and bit are removed from the hole. A specialized logging crew and equipment are brought on location. The crew assembles a probe, which is several different logging tools connected together. Depending on the number of tools in the assembly, the probe may be 70 to 120 feet in length. Using diverse scientific techniques, each tool performs a different kind of measurement of the rock and fluid properties within the geological formations surrounding the wellbore. The probe is lowered down into the wellbore on a wire line until the top of the probe is below the target depth. The process is carefully monitored by the well logging crew and geologists. As the probe is raised back up the hole, the various logging tools are activated by computers on the surface that produce a graph called a well log, which represents the geologic properties of the layers below the surface. On the well log, the gamma ray tool measures any radiation emitted by the rocks. Rock with lower amounts of radiation is called cleaner rock, such as limestone and sandstone. These are more likely to contain hydrocarbons than dirty rock. Notice that near the top of the log, the line is relatively flat and the reading is consistently high, indicating dirty rock, likely shale. But near the bottom, the reading fluctuates because the logging tool is entering a sandy area which has little radiation and could contain oil or gas. This data is called the apparent water resistivity curve. It indicates the potential for water in the rock formations surrounding the wellbore. At the top of the log, the line is at the left, which indicates more than likely the formation is wet or shaly. As we move down the log, the measurements change drastically. This indicates a quickly changing mixture of shale or other water-bearing formations on the left, to sand with the possible presence of hydrocarbons as the curve moves to the right. This next reading, called the spontaneous potential curve, shows geologists when the instrument passes from one rock formation to the next. The spontaneous potential tool uses two sensors, one at the surface and one down the hole, to compare the natural electrical charges at the surface with the underground rock. Some layers of rock have a positive charge compared to the surface, while others have a negative charge. A shift to the right on the log indicates a positive charge, usually associated with shale. A shift to the left indicates a negative difference, usually associated with sandstone. The center section of the log shows readings from the resistivity tool. The overlapping lines are 6 resistivity curves, each one measuring at a different distance from the wellbore how well the rock conducts electricity. The left side of the grid shows less resistance to electricity, while the right side denotes greater resistance. Oil or gas-bearing rocks are less conductive and therefore more resistive to electrical currents. Notice that for most of the vertical distance, the rock has less resistivity. This is likely shale. A higher resistance is likely an indicator of sand, a layer that can hold hydrocarbons. The reading from the neutron porosity tool, which can count how many hydrogen atoms are in the surrounding rock, can be seen in this section of the log. A higher concentration of hydrogen indicates the possible presence of oil. When the curve moves to the right, this indicates fewer hydrogen atoms. So as we move down the wellbore, we can see that the amount of hydrogen is generally decreasing. This means there is either very tight rock that cannot hold oil, or gas may be present. Working in tandem with the neutron porosity tool is the density porosity tool. It measures the space between the electrons in the rock, also known as bulk density. Near the top of the log, there is a greater amount of density. But as we move down the wellbore, the log indicates that the rock is becoming less dense. You'll notice that in this section, the density porosity curve and the neutron porosity curve cross over. This is significant. Whereas the neutron curve indicates either tight rock or gas, the density porosity curve tells us that the rock is more porous and therefore cannot be tight rock. This area indicates the high probability of natural gas. The next curve represents the measurements taken by the sonic tool. It shoots sound waves into the formation and records the time they take to return. Dense rock will have a faster travel time, while porous rock will be slower. Finally, on the left edge of this section, we see the reading from the caliper tool, which measures variations in the size of the wellbore. These variations can affect the accuracy of the other tools on the probe. So based on this measurement, the computer recalibrates the readings from the other tools as necessary. These are the most common logging tools used by oil and gas companies to gather information about the rocks and any fluid or gas content thousands of feet below the surface. There are numerous other tools designed for specific logging situations. The more complicated the geology is, the more diverse the set of logging tools needs to be. None of these tools by themselves can provide sufficient information to make an informed assessment about the well. But combined, these tools offer a more comprehensive and reliable perspective. When trained geologists look at well logs such as this, there is enough information for them to literally envision what the subsurface looks like. Because most wells are logged, oil and gas companies can research these logs to evaluate prospective drilling sites. When a company plans to drill in a new area, they can look at the logs of nearby wells called control wells. Lining up the logs, adjusting for variations in the surface altitude of each well, the geologist can get a good idea of the rock structure and possible presence of hydrocarbons across the area. This information is very helpful in identifying promising well sites before drilling begins. With this information, oil and gas companies can drill new wells with greater confidence and promise of success.
So I gave a understanding why this is required, why the wells are drilled, what is logging is about. It's not a one-day job, but you have something in your mind now that there is something called drilling, there is something called casing, there is something called bit, and then there is something called logging. Okay? There are many logs. On the first track we have gamma ray and we have caliper and SP. On the second track we have resistivity log, and on the third track we have those porosity logs. And those are all acquired. Logging happens from bottom to top, are acquired on various wells to give an idea where we should drill next. Thank you very much. We'll meet tomorrow and we'll see more on these subjects. Because I wanted the full house. They missed a lot. I don't